This is RD Sharma solution class 12. Chapter 19 exercise is 19.30 Indefinite integrals. Now whenever we talk about this form of integral, indefinite integral, that is the integration of rational algebraic functions by using partial functions. Now what is this form? There is a function fx and divided by a function gx. These are two separate functions and we are integrating it, indefinite integral. Now what is the degree? See, if you have x square as the numerator and x cube as the denominator, 2 is the degree of the above one and 3 is of the below one. Now this fx, if the degree of fx is less than the degree of gx, that is the power, the highest power you can say, then we call it as the proper rational function. What do we call it? Proper rational function. But if the case is reversed, the degree of fx, that is the numerator, is greater than the degree of denominator, then we call it as improper rational function, IRF. So if you just take an example, x by x square plus 1, fx is fx and gx is x square plus 1. Now this is an improper rational function or proper rational function. The degree is 1 of the numerator, 2 is of the denominator, 1 is less than 2, that is, it is a proper rational function. Now let's take an example, x cube by x square plus 1. Numerator, the degree, the highest power is 3 and then x square is 2, so it will be IRF. Now what kind of questions we are going to get, what kind of relationship we are going to get if you have a linear function px plus q and in the denominator you have x minus a into x minus b. Now this two, x minus a and x minus b, are factors. So the numerator is linear equation, denominator is a quadratic equation. The power or the degree of the numerator is less than the degree of the denominator. Now if you have this x minus a, x minus b, sometime you will not have it. You have to form the factors. So whenever we write the answer, you have to convert this px plus q by x minus a into x minus b as like a divided by x minus a. Then you take a constant b, a and b are the constants, and then x minus b in the denominator. So two factors, two values or two terms. One with the denominator x minus a, one with the x minus b as the denominator. Now this a and b will be evaluated, then we will integrate these two terms separately. Now what is the second form? Px plus q divided by x minus a whole square. So px plus q, which is a linear equation, we have x minus a whole square, which is again a quadratic equation, and this is a proper rational function. We don't use it or use the first kind of relationship. Here what we do is, again we have to have a and b, and you can have a plus because even if it is negative, b will come in negative. In the first part we have x minus a in the denominator, x minus b in the denominator, because x minus a and x minus b were multiplied in the denominator. Here you have x minus a into x minus a whole square. So a by x minus a and b by x minus a whole square. Now coming to the fourth one, actually I'll just talk about the third one. Fourth one is important because it is related to this one. If you have px square plus qx plus r, which is a quadratic equation, and the denominator has x minus a, x minus b, but x minus a has a square, then what do? The degree is 2 of the numerator, 3 of the denominator. It's a proper rational function. The first thing we'll write is a, and it is x minus a whole square. So you can call it as x minus a into x minus a into x minus b. So there are 3 separate things, but you'll not write like that: a by x minus a, b by x minus a, and b, c by x minus b. A, B, C, because there are 3 terms or 3 partial fraction kind of things. That's why we have 3 constants here. You can say that you have to use the highest order, and those number of constant has to be put in. Now x minus a whole square has to be written like this: x minus a here, x minus a whole square here, and what is remaining? X minus b. So now the third one, which is px square plus qx plus r, it is a quadratic equation which has the degree of 2, order 2. X minus a into x minus b into x minus c, these are 3 separate factors. In order to write it as a partial fraction, then because 3 terms are there in the denominator, you have a, b, c, 3 constants. Then you have x minus a, the first denominator term, the second one is x minus b, followed by third one, which is x minus c. Please remember p, q, r, a, b, c, small a, b, c is known to you. Only capital A, capital B and capital C will be computed, and then we integrate them separately. So we are forming it in an easier way. The final one is bx square plus qx plus r. That means numerator is quadratic equation. The denominator is x minus a, which is a singular term, or you can say linear equation. But here you have x square minus bx plus c, which is again a quadratic equation in the denominator. So in this case, when you have a quadratic equation in the denominator, what do you do? So it's a linear equation, so a by x minus a, x minus is a factor, it will come always, a by x minus a. Now what to do with x square minus bx plus c? Here we use the differentiation concept. You are not able to divide x square minus bx plus c into two factors. It will remain like that. So x square minus bx plus c will come in the denominator, but the numerator will only have a linear equation. That is, in the first term, if you take the differentiation of d by dx, you'll get a constant term. So you'll get a 1. But when you differentiate x square minus bx plus c, what are you going to get? So d by dx of x square minus bx plus c is 2x minus b. This is a linear equation. So you write bx plus c. Then we have to integrate them separately as two terms. Now in order to understand all of these, let's take an example. Now 2x plus 1 divided by x plus 1 and x minus 2. So numerator is a linear equation. There are two terms or two factors in the denominator which are again in turn linear equations. If you multiply them, you will obviously get a quadratic equation. So this is a proper rational thing which we discussed. So proper rational function it is. So 2x plus 1 divided by x plus 1 into x minus 2 has to be converted or has to be written as a partial function so that we can integrate them separately. So we have two factors in the denominator, you can have two constant in the numerator. Now x plus 1 come first and followed by x minus 2 in the denominator. Now there are two ways, but first thing first is LCM. Sometimes if you find problem in finding the LCM, if it is p by q plus l by m, multiply p and m, so pm plus q and l, ql divided by q into m. So this is the simple way. So here, if you are not able to find out the LCM, then the best thing is that cross multiply first. A into x minus 2 is the first term. Then you add, because plus is there in between. Multiply b with x plus 1. This will be your numerator. The denominator will be x plus 1 into x minus 2. So you'll have x plus 1 into x minus 2 in the denominator. On the left hand side, it is 2x plus 1 divided by x plus 1 into x minus 2. Now you see the denominator are same, you can just cancel them out. Now there are two ways which I am going to suggest. One will be quite easy that you are going to follow later on, I am sure. But there is another way which I am going to show it to you now. 2x plus 1 will be equal to, just multiply this. A into x minus 2 will be ax minus 2a. What will be the second one? Bx plus b. Now just combine the x term or collect the x terms. So ax plus bx, that is a plus b into x. The second one will be b minus 2a. So 2x plus 1. Now equate. 2x is equal to a plus bx. So this will be your first equation because we are equating the similar terms. So a plus b will be equal to 2 will be your first equation. Second equation is b minus 2a, which is equal to 1. Now you have two equations, two constants, so you can easily find it out. Now just write this a plus b as b plus a equals to 2. Now subtract these. So b minus b here, minus 2a minus a minus 2. Now just cancel this out. Minus 2a minus a will be negative 3a, and 1 minus 2 is again negative 1. So negative cancels out. A will be equal to 1 by 3. So a equals to 1 by 3. Now put this in the first equation or the second equation. So you'll get what? 1 by 3, which is a, plus b equals to 2. Now b will be equal to 2 minus 1 by 3, which is 6 minus 1. Again, use this p by q plus l by m form. 6 minus 1 divided by 3. This will be 5 by 3. So a and b are known now. But this is the first way you have to do. If you are comfortable with this, go along. If you're not able to do like this, it's a better way. I'll show you a very nicer way. Now when you have 2x plus 1 equals to a into x minus 2 plus b into x plus 1. Now it's quite obvious that when you put x equals to 2, 2 minus 2 will be 0 and a terms, the first term with a will be eliminated. When you put x equals to negative 1, minus 1 plus 1 will be 0, 0 into b will be 0. So the second term, second part will be eliminated. So 2x plus 1 equals to a x minus 2 2 plus bx plus 1. One time we'll put x equals to 2, the other time we'll put x equals to negative 1. So x equals to 2 here, x equals to negative 1 here. This is the second and a nicer way, easier way I'm actually explaining you. So when you put x equals to 2, 2 minus 2 will be 0, a term will be eliminated, 2 into 2 because you have to put 2 here on the left hand side also. 2 into 2 plus 1 will be equal to b, 2 plus 1. So 4 plus 1 is 5, on the right it is 3, so I'm bringing it on the downstairs, b equals 5 by 3. In the left, which I showed you, you have to solve the linear equation. Here you don't have to. Now put x equals to negative 1. So the b term will be eliminated. Now put x at every place. So 2 into negative 1 plus 1 will be equal to a negative 1 minus 2. Minus 2 plus 1 equals to a into negative 3. So negative 3 into a equals negative 1, minus minus you can cancel, a will be equal to 1 by 3. Now whichever you want to use, you can use. Now this original equation, we have just done the half part right now. So we can write this 2x plus 1 divided by x plus 1 into x minus 2 because we are integrating it. So we have a, remember, it was 1 by 3, followed by 1 by x plus 1 you can write. So this is your first term. Then the second term we got b as 5 by 3. You can write 5 by 3 here, or you can write 5 by 3 into x minus 2. So this is your second term. Now we are integrating it, and you always know that constant can be taken out. So we are integrating 1 by x plus 1, we are integrating 1 by x minus 2. Now we are integrating it with respect to dx. Remember, dx is always there. I'm not writing it, but integration of 1 by x gives you log modulus of x. Modulus because we always have a positive value inside a log. Now 1 by 3 is there, 1 by x plus 1 is log x plus 1. Then we have 5 by 3, and this will be log x minus 2. Just write log modulus of x minus 2. We cannot have a negative value inside, or cannot afford to have, and plus a constant of integration. So this is how you're going to integration of 1 by x, x minus 2, x minus 4. Now we'll do it using the partial fraction, integration by partial fraction. How do we write this? So we'll write this with, in our mind, 3 factors in the denominator. We have 3 factors, so we'll have 3 constants, a, b and c. So one by one we'll use it, like a by x, then b by x minus 2 and c by x minus 4. So actually we are integrating these 3 separate terms by evaluating a, b and c thereafter. So 1 by x, x minus 2 and x minus 4. Now we'll write it as I just suggested, a by x, b divided by x minus 2 and c divided by x minus 4. Now take the LCM now. So how to take the LCM? Sometimes it will be difficult for some students. So just multiply the denominator, all the terms, x, x minus 2 and x minus 4. Now apart from x, whatever is there, multiply it with a. That means x is already there, so you have to multiply a with x minus 2 and x minus 4. Similarly, b has x minus 2 in the denominator. So except x minus 2, whatever is in the denominator, just have it. So x into x minus 4 will be multiplied by b. Similarly, c will be multiplied by x into x minus 2, which is again without x minus 4. Now the next thing is denominator gets cancelled. So 1 will be equal to a x minus 2 x minus 4 plus b into x minus 4 plus c into x minus 2. Now the way of solving this is, first we'll put x equals to 0, b and c will go 0, then x equals to 2. If you put x equals to 2, the first term and the third term will become 0. Similarly, x equals to 4, the first term and the second term will become 0. So x equals to 0, 2 and 4 that we have to put. Now as I have just suggested, x equals to 0 will only leave a. So a, you have to put x as 0, so 0 minus 2, 0 minus 4. So this a will be equal to what? See, 4 2s are 8, so a will be 1 by 8. So 1 divided by 8 is a. Now taking x equals to 2, just put it here also, because of course x equals to 2 will become a, will make a and c term 0. Only b you are going to get here. So these two will be 0, so we don't have to worry about it. So b into 2 minus 4. So this b will be equal to 1 divided by 2 into negative 2. 2 into negative 2 is negative 4. So negative 1 by 4. Now coming to c. When you put x equals to 4, first and second term along with a and b will become 0. You will get a c here. Now put x equals to 4. So 4 minus 2. So 2 into 4 is 8. So c also has come as 1 by 8. So A, B, C we have got. Now replace these 3 in this one. Let us call it as equation number 1, and then we'll integrate them separately. So the equation becomes like this. So we have already got the partial fractions. 1 by 8 that we have got as A, 1 by x dx. What was B? Negative 1 by 4, integration of 1 divided by x minus 2. Then we have the C, which is 1 divided by 8, integration of 1 divided by x minus 4 dx. Now you already know integration of 1 by x is modulus x log. So log modulus x. So 1 by 8 log modulus of x minus 1 by 4 log modulus of x minus 2, 1 by 8 log modulus of x minus 4 plus a constant of integration. Now this is done, but if you want to make it more simplified, you can take 1 by 8 common, because we see 1 by 8 is along with 2 terms. So when you take 1 by 8, log x will remain, log x minus 4 will remain, and then c will always be there. And then here you have to multiply this by 2. Then you get 1 by 4. That's why 2 log modulus of x minus 2. Now there are 3 things I am going to use. First thing will be log a plus log b equals log a into b. So log a multiplied by b. This is the first thing. Second thing we'll use is log a minus log b is equal to log a divided by b. And third thing we'll use is a log b will be equal to log b raise a. What does it mean? The power goes inside to the power of b. So log x minus 2, the middle term, x minus 2 square will be formed. This will be log modulus of x minus log x minus 2 whole square. And you can just think it as log modulus x plus log x minus 4, that is log x into x minus 4. Then subtract it with log x minus 2 whole square, so it will go in the denominator. So let's write it like this. After combining all these, log x into x minus 4 divided by x minus 2 whole square. You can do it either way. First you can subtract log x minus 2 whole square, then add it with log x minus 4, or like this also. Eventually we are going to get 1 by 8 log modulus of x into x minus 4 divided by x minus 2 whole square. So let me write it formally, the final answer, and that is 1 by 8 ln. Log base is ln. So you can write ln also. ln x minus 4 divided by x minus 2 whole square, and inside a modulus, and then you can just add a constant of integration. That's your final answer. So a very straightforward question, and many things you have learned in this one. I hope it's clear to you. Now in this question, we have x square plus x minus 1 divided by x square plus x minus 6. Now the order is same. So we'll write it something like this. 1 plus a divided by factor 1, b divided by factor 2. Because we know that x square plus x minus 6 can be easily divided into 2 factors. Because you have 6, so 2 3s are 6. You will get a 1. So x square plus 3x minus 2x minus 6. You can take x common, x plus 3 will be there. You can take negative 2 common, x plus 3 will be there. So x minus 2 into x plus 3 is there. So you can write it as 1 plus a divided by x minus 2 plus b divided by x plus 3. Now initially I told you that this is how you're going to write this. But how this 1 has come, how this a and b has x minus 2 and x plus 3 as the denominator. So let's start with the scratch, or from the scratch, that is from the beginning. Now one thing you have to remember, that we have already computed x square plus x minus 6 as 2 factors, x minus 2 into x plus 3. So x square plus x minus 6 will give you what? This integration will be x square plus x minus 1. Just write it like this, x square plus x minus 6 in the numerator. Now you need a negative 1. How do you get a negative 1? You just have to add a plus 5. It's actually equal to x square plus x minus 1 only. But we wanted the denominator also as one term. Now let's divide x square plus x minus 6 to both the terms. That is, we have changed x square plus x minus 1 as x square plus x minus 6 plus 5. So I'm taking x square plus x minus 6 first with the denominator x square plus x minus 6. And the second term will be 5 divided by x square plus x minus 6. Now when you integrate this, dx will always be there. Remember, the first term is going to be only integration of dx. That's how 1 has come. When you cancel this, integration of dx will come. If you see, initially I told you this 1 will come from where? Here. Then you can take 5 common. Integration of dx divided by x square plus x minus 6. So this will be x square minus px plus q. If this kind of expression is there, integration by partial fraction will be 1a by px minus p and b by x minus q if you can form x minus p and x minus q as the factor of x square minus px plus q. So integration will become like this. Integration of dx will be x 5. Now x square plus x minus 6 can be written as x minus 2 into x plus 3. So just write it here, x minus 2 into x plus 3. You already have a dx here. Let's call it as I1 from here to here. Let's call it as I1. So final answer will be I equals to x plus 5 I1. We'll compute this I1 just now. Now in order to find out this I1, if you recall, we have 1 divided by x minus 2 and then x plus 3, and this will be equated to, because we have two factors in the denominator, it will be a divided by x minus 2 and then b divided by x plus 3. Now if you don't understand this, how to take the LCM, just cross multiply a with x plus 3, b with x minus 2. This is a cross multiplication. Then denominator you just multiply and write as it is, because the left hand side which I am writing x minus 2 and x plus 3 is actually equal to the denominator when we multiply x minus 2 and x plus 3. So this x minus 2 and x plus 3 will get cancelled. When you cancel it, then you get an equation 1 equals to a into x plus 3 plus b into x minus 2. Let's call it as equation number 2. First we'll put x equals to negative 3 so that the term with a becomes 0. This whole term is going to become 0. When you put x equals to 2, the b term will become 0. So let's do it respectively. X minus 3 I am placing. This first term you can just ignore because it's going to be 0. 1 will be equal to b into x is negative 3 minus negative 2. So this b will be equal to 1 by 5 in negative. When you put x equals to 2, the second term is going to be 0 in equation number 2. This 1 will be equal to a 2 plus 3. So a became 1 by 5. So if you see here, I has become, because it was initially a divided by x minus 2 plus b divided by x plus 3, a and b we have found out, so it will be 1 by 5 x minus 2, the first term, and then we have negative, so let's change this sign, negative 1 by 5 and divided by x plus 3. This was your I1 if you remember. When you want to integrate this I will be equal to x plus 5 I1. We'll put it here. Let's integrate I1 first. So this I1 will be 1 by 5 we can take outside, 1 by 5 here also we can take outside. Actually we can take 1 by 5 outside from both the terms. So this will be log modulus of x minus 2, because this 1 by x integration is log x. Log x minus 2 minus log x plus 3, and don't forget about this 1 by 5. Here also 1 by 5, you can take them outside also. Now you need to multiply this by 5 because you have to add a x after multiplying it with 5. So when you multiply it by 5, as I told you, 1 by 5 can be taken outside. When it gets multiplied by 5, all 1 by 5 will vanish. So only this log modulus of x minus 2 and minus log x plus 3 modulus x plus 3 will remain. You can also write ln, because ln is simply log base e. So log modulus of x plus 3 plus a constant of integration. This is your I. Now if you want to just make it more simplified, you can write it as x plus log a minus minus log b is what? Log a by b. You already know that. So x plus log x minus 2 divided by x plus 3 plus constant of integration. So whichever you want to keep, you can keep it. So this is the result we were talking about. I hope it's clear to you now. Now in this question, this is a quadratic equation in the numerator. We have x plus 2, x minus 1, that is we have already factors in the denominator which will form quadratic equation. So x plus 2 and x minus 1 has to be multiplied first. That means it will give you x square minus x plus 2x, and that's minus 2. So x square plus x minus 2. This integration, let's write I here. So it will be 3 plus 4x minus x square. I'm writing the denominator as x square plus x minus 2, which we have got up after multiplying x plus 2 and x minus 1. Now you have to equate somewhere or put x square plus x minus 2 or get this one in the numerator. Now first you can have this negative x square you need to have. So negative x square plus 4x plus 3. Now how to do this? I am now going to tell you the wrong approach. So I am doing something wrong, then I'll correct, and you'll see why we cannot do this. So negative x square plus 4x plus 3 divided by x square plus x minus 2 is already there with you. Now just write x square plus x minus 2 in the numerator. So what we have to add to this x square plus x minus 2 or subtract, so that we get a negative x square plus 4x plus 3. So I'm just saying x square plus x minus 2, we are adding some a to get a negative x square plus 4x plus 3. So this a will be equal to negative x square plus 4x plus 3. This goes on the right, negative x square and negative x plus 2. So this negative x square will be negative 2x square. 4x minus x is 3x and 3 plus 2 will be equal to 5. That means we have to add negative x square plus 3x plus 5 with x square plus x minus 2 in order to get 3 plus 4x minus negative x square. So I'm writing it as it is. Alright. Now just separate them out with x square plus x minus 2 as the denominator. So when you write this x square plus x minus 2 in the denominator, what do you get? This you will get as 1. But again we are left with the same issue, same problem. So this will not work. I hope you got the idea. That means you have to divide now. You have to apply some other approach. So I'm dividing x square plus x minus 2. That is negative x square plus 4x plus 3 by x square plus x minus 2. So you need a negative x square here. Multiply it with negative 1. So just negative x square. Just multiply x square plus x minus 2 with negative 1 and write it in the denominator. So this is what you get. Now subtract this. These two equations. So this will get cancelled. 4x plus x will be 5x and 3 minus 2 will be plus 1. Now the same thing here is, how do we write this? First we write negative 1, then we have 5x plus 1. In the numerator and denominator is x square plus x minus 2. Now if you check this, just take the LCM and you will get the same equation from where we started. Alright, so you understood the wrong approach, and or the better approach is to do this which I just showed you. Now you have to integrate this term. So this I will be equal to integration of negative 1 dx, then the integration of 5x plus 1 divided by x square plus x minus 2 dx. Integration of dx will be negative x, and the I1 integration, which is 5x plus 1 divided by x square plus x minus 2, we'll just do it now. So this I1 has come as 5x plus 1 divided by x square plus x minus 2. We have already done that. I assured you that we are going to use this. But we need to use the factor, and factor is already there with us. So this ax plus b divided by some form of quadratic equation will give you a divided by x minus 1. You can write it like this. A divided by x minus 1 and b divided by x plus 2. You can write x minus 1 and x plus 2 either way, that is the first term or the second term. So I'm writing x minus 1 as the first term, x plus 2 as the second term. So eventually you have to integrate these two. But before that, you have to get the a and b. So just take the cross multiplication or the LCM. A into x plus 2 plus b into x minus 1 divided by x minus 1 into x plus 2, which is on the left hand side also. So left hand side and right hand side both have x plus 2 and x minus 1. So just cancel these two out. This x now you have to put as negative 2. That will eliminate the a term. So let's put x equals to negative 2 and then x equals to 1 here, so that we eliminate the b term. So we'll put x equals to 1 in second step. So 5x plus 1 will be equal to a into x plus 2 plus b into x minus 1. In this equation, which is equation number 1, I am indicating. So 5 into negative 2, I am writing negative 2 in place of x, will be equal to b, and negative 2 negative 1 will give you negative 3. So this will be negative 10 plus 1 equals to b into negative 3, and then negative 9 equals to b into negative 3. 9 and 9, when negative gets cancelled, b equal to 3 3s are 9, so b will be equal to 3. So we have got b equals to 3. Now put x equals to 1 in this equation number 1. So the second term will become 0. You will get an a from here. So 5 into 1 plus 1 equals to a 1 plus 2. So 5 plus 1 is 6, a, this is 3. So you get a equals to 2. So we have a equals to 2, b equals to 3. Put it in this equation here. So let me write it here. I1 I called it initially. So this will be a is 2, b is 3. So just change it. 2 divided by x minus 1. b is 3, 3 divided by x plus 2. Now we have to integrate this. When you integrate this, you can take this constant 2 as a constant. So I1 will be 2 integration of 1 by x minus 1 dx plus 3 integration of 1 by x plus 2 dx. This will be 2 log modulus of x minus 1 plus 3 log modulus of x plus 2 plus a constant of integration. But if you remember, there was a first term which I called that we are going to add it, negative x, and then followed by these two terms. So we have plus 2 log modulus of x minus 1 plus 3 log modulus of x plus 2 plus constant of integration. This is your final answer. So this is the reference. This is what are the steps you need to follow. The main thing is the logic is my responsibility. But all these putting x plus 2 equals to 0, which I speak, you have to write it. Alright. So the concept, if you understand, you can write English always. It's up to I know that you'll be able to do that. In this question, x square minus 1, it's obvious that it is x minus 1 into x plus 1. We'll talk about that, but we will like to write the numerator in the form of the denominator. For that, just write the denominator as a numerator, add 2. It will form x square plus 1 only. So this integration will become something like this. So integration of x square minus 1 plus 2 divided by x square minus 1. If you notice, the numerator will become x square plus 1 only. Now separate them out. That is x square minus 1 in the denominator, and here also the x square minus 1 in the denominator. So the numerator will get cancelled with the denominator here. You will get 1. Here you will get 2 divided by x square minus 1. So the integration will be something like this. Integration of 1 dx and integration of 2 divided by x square minus 1. So integration of 1 dx is x. 2 you can take outside. Integration of 1 by x square minus 1 dx. Now from here to here, let me call it as I1 and we'll do it separately. So this I1 will be 1 divided by, you know that a square minus b squared is what? A minus b into a plus b. That means x square minus 1, you can write it as 1 square. So it will be x minus 1 into x plus 1. A minus b into a plus b. So let's write it here, x minus 1 into x plus 1. So how to write it as a partial fraction? Because there are two factors in the denominator. We have a and b, two constants here, divided by x minus 1 and then divided by x plus 1, and we have to integrate this now. Before that, we need to find out this capital A and capital B as constants. So 1 by x minus 1 into x plus 1 has been written like this. Let's cross multiply so that we find the LCM. A into x plus 1 plus b into x minus 1 divided by x minus 1 into x plus 1. Now this x minus 1 and x plus 1 will get cancelled. So the equation becomes 1 equals to a into x plus 1 plus b into x minus 1. This equation number 1, first we'll put x equals to negative 1 and then we'll put x equals to 1. Why? Because x equals to negative 1 will make this a into x plus 1 as 0. So you'll get a b here. So 1 will be equal to b. In place of x, write negative 1. So negative 2b equals to 1. b becomes negative 1 by 2. When we place x equals to 1, this b term, that is 1 minus 1 will be 0. So b term will become 0. From here you will get a. So 1 will be equal to a. I am putting x as 1 here. So 1 plus 1. So a will be equal to half. A and b we got. So in this place a, we are going to replace it by half. B will be replaced by negative half. Now this I will become like this. I equals to x square plus 1 by x square minus 1 will be equal to a and b we have already found out. The first term was x. Integration of dx was x. So x plus 1 by 2 we can take outside. Integration of 1 by x minus 1. Then minus half integration of 1 by x plus 1. So x plus half 1 by x minus 1 will be log modulus of x minus 1. Then minus half modulus of log modulus of x plus 1. Because log inside that everything will be under modulus, we cannot have a negative log. We can combine the second term and the third term after taking half outside. I told you that x plus 2 into I1 is the final result. So we already have a 2. So when we multiply this by 2, this half gets cancelled. If you take half outside, multiply it by 2, this gets cancelled. So we have log a minus log b, and log a minus log b can be written as log a by b, a and b will be in the modulus sign. So x plus this log x minus 1 minus log x plus 1 will become ln. You can write ln for log AC. ln modulus of x minus 1 divided by x plus 1 plus constant of integration. This is your final answer. So how we are going to go about it? It's a very straightforward question because we are doing the first few questions because there are 60-70 questions here, so you'll understand it better. Next one is x square divided by x minus 1 into x minus 2 into x minus 3. So we have 3 factors in the denominator. We'll deal with this integration later on, but first we have to devise a technique to find out this integration in terms of partial fractions. So x square divided by x minus 1 into x minus 2 into x minus 3, and this will be equal to a, b, c. 3 terms are 3 constant we are using just because 3 factors are there. Now you can have any factor anywhere. So you can have a by x minus 3, b by x minus 1 and c by x minus whichever you want. So you can just change because depending on that a, b and c will be changed. It will be evaluated. Let's take the LCM. It's very easy. If you have any confusion, just multiply the 3 terms in the denominator first. X minus 1, x minus 2, x minus 3. This will come as a denominator. Now in a you have x minus 1 in the denominator. So except x minus 1, other terms you have to multiply with a. that is x minus 2 into x minus 3. Similarly, b has a denominator x minus 2. So other than x minus 2, you can have x minus 1 and x minus 3 multiplied by b. For the third one, what do you have below c, x minus 3? So except x minus 3, x minus 1 and x minus 2 is remaining, so you just multiply this. So we have x squared divided by x minus 1 into x minus 2 and x minus 3. Just cancel these. Now if you place x equals to 1, 2 terms will be 0. X minus 2, x equals to 2, 2 terms will be 0. That's how we'll go about. So when you put x equals to 1, c and b terms will get say vanished. So this 1, when you put x as 1, 1 square will be 1, will be equal to a into 1 minus 2 into 1 minus 3. So 1 will be equal to a, negative 1, negative 2. So this a will become 1 by 2. Now put x equals to 2. So the first and the third term will become 0. Only b will come. So when you put x equals to 2, this left hand side will be 2 square. On the right it will be b into 2 minus 1 and 2 minus 3. So 4 will be equal to b 1 into negative 1. b is negative 1 by 4. Negative 4, sorry. Now the third one will be x will be equal to 3. When you put x equals to 3, the second and the first term will vanish. Only the c will be evaluated. On the left you have to put x equals to 3. So 3 square will be equal to 3 minus 1 into 3 minus 2. So 9 will be equal to 3 minus 1 is 2, c into 2 and 1. So c became 9 by 2. Now a, b, c you have to put in here. So this integration will be like this. Integration, these 3 integrations, separate terms, and all in terms of dx, integration with respect to dx. So a is a constant, half, you can take it outside, integration dx divided by x minus 1. Now coming to b, b is negative 4. When negative 4 you can take outside, dx divided by x minus 2. Then c, and c is 9 by 2. So you can have 9 by 2 outside. Integration of dx divided by x minus 3. So you have half log modulus of x minus 1. You can write it as ln also, because ln is log base e. It represents more logical thing rather than writing log. Minus 4 log modulus of x minus 2 plus 9 by 2 log or ln modulus of x minus 3, and then plus constant of integration. So this is your final result. Now if you want to do it by yourself, this is the way you are going to go about it. I am suggesting that this question, because they are initial questions, we need some practice. In this fx divided by x plus 1, x square minus 4. Now x square minus 4 is straightforward in a way. X square minus 2 square you can write. So x square minus 2 square is a square minus b square. It will be a minus b into a plus b. So x square minus 2 square can be written as x minus 2 into x plus 2. This integration will become like this. So we have 5x divided by x plus 1, and the two terms which we got from x square minus 4 has to be written here, x minus 1 into x plus 1. No, x minus 2 into x plus 2, sorry. So we'll just talk about integration in a bit, but before that we have to integrate in terms of partial fraction. So 5x divided by x plus 1, x minus 2, x plus 2. You can write it any order, it doesn't matter. So now there are 3 factors in the left hand side, so you have to have a 3 constant on the right. So a and b and c you can write, because there are 3 constants for 3 factors. And now you can put any value below any constant. Okay, you don't have to follow a scheme. You can have a divided by x minus 2, b divided by x plus 1, or whichever way you want, because a, b, c will be evaluated accordingly. So the next thing will be what? In the denominator, you can multiply these 3, x plus 1 into x minus 2 and x plus 2. So when you multiply this will be your denominator, x plus 1, x minus 2 and x plus 2. Now we have a, except x plus 1, take everything, x minus 2 and x plus 2. Below b it is x minus 2, so except x minus 2, take x plus 1 and x plus 2. Below c it is x plus 2, so except x plus 2, take everything like x plus 1 and x minus 2. Now after this, left hand side, 5x divided by x plus 1 into x plus 2 into x minus 2. The denominator gets cancelled. So the equation which is remaining, that is both the numerators on left hand side and right hand side, it forms an equation. Now when you put x equals to 2, this term goes 0, these terms become 0. So this 5x is 2, 5 into 2 will be equal to 2 plus 1 and 2 plus 2. Of course, there is a constant term. Right, b is always there. So 5 2s are 10 on the left hand side. 2 plus 1 is 3, goes in the denominator. 2 plus 2 4 goes into the denominator. b equals 10 divided by 3 into 4, which becomes 5 by 6. This is the first constant we evaluated. Second is x equals to negative 2. put it like this. When you put this, x equals to negative 2. 5 into negative 2 will be equal to negative 2 plus 1, negative 2 minus 2. So negative 10 on left hand side. You have a c along with this. This is negative 1. This will be negative 4. So minus minus become plus on the right hand side. So only negative will remain on the left. This will give you c as what? C will become 5 by negative 5 by 2. C became negative 5 by 2. Now what is remaining? Put x equals to negative 1. So when you put this, because B and C we have already evaluated, so only the A will remain. So put x equals to negative 1 on the left hand side, 5 into negative 1. A into negative 1 minus 2 and negative 1 plus 2. So A became what? 5 by 3. So B is 5 by 6, C is negative 5 by 2, A is 5 by 3. Now put it here. A is 5 by 6, B becomes what? This 5 by 6, whichever way, A, B, C we have computed, and just put it there. When we place this A, B, C, this integration become like this. So 5x divided by x plus 1 into x square minus 4 you can write, or you can write x minus 2 into x plus 2, it's one and the same thing. This integration will be equal to, so A was 5 by 3. If you get any A, B, C different, don't worry about that. Okay, just understand the concept. A, B, C can be different of what you have evaluated or what I have evaluated. So 5 by 3 dx by x plus 1. B is 5 by 6 in this case. Integration dx divided by x minus 2 minus 5 by 2. Integration dx divided by x plus 2. Let me reiterate, you can get the A, B, C value different. Okay, I can have different values because it's just what you have put in below A, B and C. So this becomes 5 by 3 log modulus of x plus 1 plus 5 by 6 log modulus of x minus 2 minus 5 by 2 log modulus of x plus 2 plus constant of integration. Now you can make it more easier because you see 5 by 3, 5 by 6, 5 by 2. We have 5, 3, 6, 2 as some, you can have a proper HCF. So you can take 5 constant outside. So if you take 5 by 6 constant from all the values, 2 will remain inside. So 2 log modulus of x plus 1 will be the first term. You can write ln also. So 2 log x plus 1. The second will be what? You can have ln or log. So ln modulus of x minus 2. Now if you take 5 by 6, you have to multiply this with 3. So this will become minus 3 ln modulus of x plus 2 plus constant of integration. So a log b equals log b raise a, b to the power a. Now this goes to the power, so this will be log x plus 1 square plus ln, just write ln modulus of x minus 2, there will be no change here. But here third term, the x plus 2 will gain a power 3 from the number which is in front of ln. Now what is log a plus log b? Log a into b. What is log a minus log b? Log a by b. So first you can take this x plus 1 whole square into x minus 2 and then you can have a subtraction. So x plus 2 comes in the denominator. You can have a 5 by 6 in front. Now let me write this in a formal way. The final answer will be 5 by 6. This integration becomes 5 by 6 log modulus for all x minus 1 x plus 1 whole square then multiplied by x minus 2 divided by x plus 2 whole cube modulus n plus constant of integration. This is your final answer. Now this is how you can do it. It depends on what you have placed below A, B, C. So the answer will come, or the A, B, C will come differently, but the answer will come same. So if anything is remaining or you miss something, you can follow this reference. X square plus 1 divided by x into x square minus 1. Now this x square minus 1 in this integral can be written as, because we know that a squared minus b squared is x square minus 1 square in this case, and we can write it as x minus 1 into x plus 1 because a square minus b square is a minus b into a plus b. A is x here, b is 1 here. So first we will use the partial fraction or try to transform it to in the form of partial fraction. So this x square minus 1 I have written as x minus 1 into x plus 1. So this will be a divided by x plus b divided by, there are 3 factors, therefore we need 3 constants, b divided by x minus 1 plus c divided by x plus 1. So the first thing, the left hand side will remain the same, the right hand side will take the LCM. So x minus 1 x plus 1 in the denominator on the right hand side, after taking the LCM, x into x minus 1 into x plus 1 will come. Then except x, others will be multiplied by a in the numerator So a multiplied by x minus 1 into x plus 1. Then b multiplied by everything except x minus 1. So b multiplied by x plus 1. Now c, except x plus 1, multiply x and x minus 1. Now this x can be written as 0, can be placed as minus 1 and can be placed as plus 1. In order to get a, b, c, the denominator gets cancelled. Assume that the numerator is equation number 1. When we place x equals to 0 on both the sides, 0 square plus 1 will be equal to a into 0 minus 1 and 0 plus 1. So 1 will be equal to a into negative 1 into positive 1. So it is negative a. So a became negative 1 here. The second thing is x will be placed or replaced by x equals to 1. So the first and the last term will become 0. So b will remain. We are putting x equals to 1 on both the sides. 1 square plus 1 equals to b into 1 plus 1. 2 equals to b into 1 plus 2. 1 into 2. So b became 1. The third thing is we'll place x equals to negative 1. So the first and the second term will become 0. C will get. So both the sides you have to place x equals to negative 1. So negative 1 whole square will be equal to negative 1 whole square plus 1 will be equal to c into negative 1 into negative 2. Minus minus become positive 2 here to there. So c will be equal to 2. So this equation will be formed like this. Negative 1 divided by x. In place of b it will be 1 divided by x minus 1. In place of c it will be 2 divided by x plus 1. Now when we will integrate these three different terms with respect to x, like this, negative 1 will take outside and this is the integration. Alright, c is 1 here, okay? Please remember c is 1. So I became like this, and this is negative integration of dx by x plus dx by x minus 1. And if you remember, 2 equals to c into 2. So by mistake I have written c equals to 2 there. It is c equals to 1 here. So integration of dx by x plus 1. First became negative log modulus x because 1 by x is log x. Here also log. Whenever I am saying log, you must consider is to be ln. ln is log base e. Now we have 2 plus term, 1 negative term. So log a plus log b. So log a plus log b will give us log a multiplied by b. So then let's write it, plus log ln x minus 1 into x plus 1. So this will be x square minus 1. Now we have ln x square plus 1 minus ln x. So you have two terms here, negative ln x plus ln x square minus 1. So log a minus log b. Now we'll apply this result. So log a minus log b will be equal to log a divided by b. This will be equal to ln x square minus 1 divided by x. So take the modulus plus constant of integration. So whatever we have discussed, same thing I have done here, or this is the reference for you, those who are doing it by themselves. And this is how you have to write actually. All these English putting and equation number 1 or 2, this you have to give. 2x minus 1 divided by 2x minus 3 divided by x square minus 1 into 2x plus 3. Call it as an integral. First we will try to make it this integration as a partial fraction terms. 2x minus 3 divided by x square minus 1 we have just done. So x minus 1 into x plus 1 divided and 2x plus 3 is already there. Now write this a divided by x minus 1 plus b divided by x plus 1 and c divided by 2x plus 3. On left it will be same. I'll just write it. I'm writing do just for a while. In the denominator you will get x minus 1 multiplied by x plus 1 multiplied by 2x plus 3. Now a will have except x minus 1 other members x plus 1 and 2x plus 3. With b except x plus 1 other two factors. What are those? X minus 1 into 2x plus 3. Now with c except 2x plus 3 other factors like x minus 1 into x plus 1. So let me write this left hand side so that we can cancel it out. Denominator is same as the right hand side. The numerator is 2x minus 3. Now cancel this denominator and call it as equation number 1. The numerator, call it as the equation number 1. So the equation number 1, let me write it because it's very important. 2x minus 3 will be equal to a into x plus 1 into 2x plus 3 plus b into x minus 1 into 2x plus 3 plus x minus 1 into x plus 1. C is here. We will find out a, b, c. First we will put x equals 1. When we put x equals to 1, only the first term will remain. The second and third term will become 0. So 2 into 1 minus 3 will be equal to a into 1 plus 1 and 2 into 1 plus 3. 2 minus 3 will be equal to a into 2 plus 5 into 5. 2 into 1 plus 3 is 5. So negative 1 on the left, 10 on the right. So a became negative 1 by 10. Now coming to the other two constants b and c. We'll put x equals to negative 1. So the first term will become 0 and this third term will become 0. So we'll get a b here. Replace x equals to negative 1 everywhere. On the left also you have to do the same. 2 into negative 1 minus 3. So minus 2 minus 3 is negative 5 equals to b. Negative 1 is negative 2. 3 minus 2 is 1. So negative you can cancel. B became 5 by 2. Coming to the third constant. Now we'll put x equals to negative 3 by 2. How did I get it? If you put 2x plus 3 equals to 0, at what value of x 2x plus 3 will become 0? It will be x equals to negative 3 by 2. So that's why we have to replace or put x equals to negative 3 by 2 in order to get c. So I'm replacing left and right hand side all x by negative 3 by 2 and we know that the first and second term will be 0. Only the third term with c will remain. So this will be negative 3, negative 6. On right it will be 1 minus 3 by 2 will be simply 2 minus 3 by 2, that is negative half. Negative 3 by 2 minus 1 is negative 5 by 2. Okay, there is no cancellation, only the negative gets cancelled and minus is plus. So C will be equal to 6 to the 12, 12 to the 24, 24 divided by 5 and with a negative sign. So A, B, C we have got. So what is the next step we are going to do? We'll replace A, B, C in this equation. This is how we are going to integrate. A will be negative 1 by 10. B will be 5 by 2 and C will be negative 24 by 5. So this is your I. I will be equal to, it was negative 1 by 10 A. So D in negative 1 by 10 integration of dx by x minus 1. The second term was 5 by 2 integration of dx divided by x plus 1. The third term was negative 24 by 5 integration of 1 by 2x plus 3 dx. Negative 1 by 10. This will be ln modulus of x minus 1. Then we have 5 by 2 ln modulus of x plus 1 minus 24 by 5 ln modulus of 2x plus 3. Now this 2x plus 3 will be differentiated also. So 2 will come and that will be divided. So you'll get a 12 by 5. That will be your final answer. But if you want to keep it like this, then also it's okay. So I'm just showing you this one. I hope you got the idea why this 12 by 5 has come. Because differentiation of 2x plus 3, 2 will be cancelled by 24 to get 12. X cube divided by x minus 1 into x minus 2 into x minus 3. Now you have x cube in the numerator, x cube in the denominator. If you multiply x minus 1, x minus 2, x minus 3. So the power remains the same in the numerator and denominator. For that you will get a 1 plus. If you remember the first discussion we had when I was telling you all the results which we are going to follow in this exercise. So 1 plus. How this 1 plus has come? We will divide them because the power or the order of numerator and denominator are same. That is the reason why we are doing it. Let's multiply x minus 2 and x minus 3 first. It will be x square minus 3x minus 2x plus 6. X square minus 5x plus 6. Now multiply it with x minus 1. So x cube minus 5x square plus 6x, then minus x square plus 5x minus 6. Once I multiplied with x, once I multiplied it with negative 1. So x cube, then negative 6x square, this all dealt 6x and 5x will give you 11x and minus 6. So this is your denominator. Now we need to divide, you need to divide x cube. So x cube minus 6x square plus 11x minus 6. Now the division will take place like this, x cube here. So in order to get x cube, you have to multiply this with 1. So x cube, everything will remain same because only multiplication of 1 will not change anything. But now you have to subtract these. X cube will get cancelled. And all others will change the sign. That is, you will get 6x square here minus 11x minus plus 6. So this you will get. Okay. Now this one, there is a slight change in that sign. You understood that. Okay. So 6x square plus 11x. So let me write the denominator now. X minus 1 into x minus 2 into x minus 3. So this integral has come. So when you integrate this integration of first term will be simply x plus. But remember, this is 6x square minus 11x. There is only one change. Okay. So let's call it as I1, which we are finding out. I1 was after the change of that sign which I told you. 6x square minus 11x plus 6 and divided by, when you multiply this, you will get something, but I am writing it as it is, as I haven't multiplied it. Now because the order of the numerator is less than the order of the denominator, now we can have a, b, c, because 3 factors are there in the denominator. So you have a divided by x minus 1 plus b divided by x minus 2 plus c divided by x minus 3. Now cross multiplication. 6x square minus 11x plus 6 divided by x minus 1 into x minus 2 into x minus 3. Now you will take the LCM here. So all these will be multiplied and kept in the denominator. X minus 1 into x minus 2 into x minus 3. A will have what? Except x minus 1 other things like x minus 2 and x minus 3. Similarly, except x minus 2 other factors just multiplied by b. X minus 1 into x minus 3. And with c what will come? Except x minus 3, x minus 1 and x minus 2 will come. Now you just cancel these denominator and assume that the numerator is equation number some certain one. This is just an equation. Now we'll try to find out the a, b, c, which are the constants. Now in this equation, which I am calling it as equation number 1, place x equals to 2. So when you put x equals to 2, the first and the third term will become 0. You'll get a b from here. So 6 into 2 square minus 11 into 2 plus 6 equals to b into 2 minus 1 into 2 minus 3. 6 into 4 minus 22 plus 6 will be equal to b into 1 into negative 1. 6 4s are 24, minus 22 is 2, 2 plus 6 is 8. 8 equals b into 1 into negative 1. So b become 1 negative 8. In the next one, x minus 3 will put 0, that is x equals to 3 will put. So the first and the second term of the equation number 1 will become 0. C you are going to get. 3 you have to put in the left hand side also wherever you get x. So 6 into 3 square minus 11 into 3 plus 6 will be equal to b into 3 minus 1, not in here. So c into 3 minus 1 and 3 minus 2. So 3 is a 9, 6 9s are 54, 54 minus 33 plus 6. So this 54 minus 33 plus 6, that is 60 minus 33, 27 you will get. On the right it will be c into 2 into negative 1, sorry. So c became 27 by 2. Now coming to the third one, x will be placed as 1. So only a will come because b and c component will become 0. 6 into 1 square minus 11 into 1 plus 6. And this became a into 1 minus 2 and 1 minus 3. So 6 minus 11 plus 6. So 12 minus 11 is 1 only. On the right it's a into 2. So a became 1 by 2. A, B, C we got. Now here we are going to replace a by half, b by negative 8, c by 27 divided by 2. And we'll do the integration. So let me do the integration after taking out all these constants outside. So I1 became, after finding out ABC, half I'm taking outside, integration of dx divided by x minus 1 minus 8 integration of dx divided by x minus 2 plus 27 divided by 2 integration of dx divided by x minus 3. So half log ln you can write, log by c is ln only, modulus of x minus 1, 8 ln modulus of x minus 2 plus 27 divided by 2 ln modulus of x minus 3. So if you remember, I was x plus I1. So just let me add x, this became I. So x plus half into ln x minus 1 minus 8 ln x minus 2 plus 27 by 2 ln x minus 3 plus a constant of integration is your final answer. Now this is the result, or this is the reference or the solution you can refer if you are doing it by yourself, and all about this English writing and the equation numbers you have to give the way you see it here. Logic I told you. Now in this question we have trigonometry and we have to solve it accordingly. So what all we have done in the previous 10 questions, the question remains the same. When we put t equals to sin x, this t equal to sin x will give you dt by dx will be equal to cos x. So dt became equal to cos x dx. This I will be equal to, the sin 2x will be what? 2 sin x cos x. But cos x dx is already dt with us. Now if you write this integral like this, sin 2x as 2 sin x cos x, dx is already there. In the denominator it will be 1 plus sin x and 2 plus sin x. 2 plus sin x, so the integration here, cos x dx is already with us, which is dt. And sin x we have already assumed to bt. So 2 we can take outside, 2t, t for sin x, dt for cos x dx. Denominator sin x replaced by t1 plus t and 2 plus t. Now we need to integrate this. For that, if you take 2 outside, this is what we have to integrate, and we'll use the partial fraction for the same. So t divided by 1 plus t into 2 plus t, that has to be equated with, because two factors are there, we'll use a and b, capital A and b. A divided by 1 plus t, b divided by 2 plus t. A multiplied by 2 plus t plus b multiplied by 1 plus t. The denominator will give you 1 plus t into 2 plus t. Left hand side become t divided by 1 plus t and 2 plus t. We get cancelled. Cancellation of the denominator. Let's call it as equation number 1. So one time we'll put at t equals to -2, one time we'll place t equals to -1, and then we'll get the integratable values or factors. So t equals to a into 2 plus t plus b into 1 plus t. This is what we have got already. So put t equals to -2 first, both sides. So this a term will become 0, b into 1 minus 2 will come. That is -2 plus 1. So -2 will be equal to b into -1. So b equals 2. Now coming to the second constant, t, just place it as -1. So the second term will become 0. So -1 will be equal to a into 2 minus 1. -1 will be equal to a into 1. A became -1. So the equation, if you remember, it was 2 integration of -1 divided by t plus 1 plus 2 divided by t plus 2. This is integrable now. So 2 into integration of minus, if you take outside, integration of 1 by t plus 1 will be equal to ln modulus of t plus 1. So log modulus of t plus 1, log base is ln. So ln modulus of t plus 1. Now 2 will be multiplied by 2 inside for the second term. It will give you 4. So plus 4, and then the integration of dt divided by t plus 2. So when you have dt divided by t plus 2, it will give you log base e or ln modulus of t plus 2. So this will be ln modulus of t plus 2 plus a constant of integration. So you have -2 in front, you have 4 in front. You can take this to the power. That is, just write it as 4 ln t plus 2 minus 2 ln t plus 1. That will be easier. 2 will go to the power. So ln t1 plus to the power 2, ln t plus 2 to the power 4. Now you know log a minus log b is log a by b. A log b is log b to the power a. And log a minus log b is log a by b. That's what we are employing here. So we'll get ln t plus 2 to the power 4, t plus 1 to the power 2 in the denominator, plus c. And this I, if you remember, t we have taken as sin x. Now replace wherever you get t as sin x. So ln, just replace t by sin x. So sin x plus 2 raised power 4, and then sin x plus 1 raised power 2 plus constant of integration. This is your final answer. And how you are going to go about it, it's in front of you, and this is the way you have to solve this. Now 2x divided by x square plus 1 divided by x square plus 3. Now we have x square into x square, that is x raised 4 in the denominator, only x in the numerator. But if we just take this x square equals to t, that is, we will try to minimize the effort. When we differentiate dt by dx will come as 2x. So what are you going to get? Dt will be equal to 2x dx. So this 2x and dx will give dt. We'll replace this here. So this integration will become like this. Integration of dt divided by, after replacement of x square with t plus 1, first factor, and t plus 3 as another factor. So we will try to form partial fractions out of this. That is, right now we are not integrating, we are just trying to form partial fractions out of this 1 by t plus 1 multiplied by t plus 3 in the denominator. So this will be equal to a divided by t plus 1, and then b divided by t plus 3. So this is 1 by t plus 1 into t plus 3. This equals cross multiply, that is a with t plus 3 and b with t plus 1. And denominator will give you t plus 1 into t plus 3. The denominator gets cancelled. So this is equation number 1. If we place t equals to -3, the first term of the right hand side of equation number 1 will vanish. So we have t equals to -3 on the left and right also. So we will get b equals to negative 1 by 2 here. Now when we place t equals to negative 1 or replacement of t equals to negative 1 will give the second term the value 0. So a we will get from here after replacing t equals to negative 1. So 1 will be equal to a into 3 minus 1 which is 2. A became 1 by 2. So we'll place a as half and we'll replace b by negative half and then we will integrate. So the integration will be like this. Integration equals to half integration of dt divided by t plus 1 minus half integration of dt divided by t plus 3. So we know integration of 1 by x or 1 by t with respect to dx or dt will always give you log. So log modulus of x or log modulus of t. This log is log base e. You can always write interchangeably ln also in this place. So half ln modulus of t plus 1 here and then we have ln modulus of t plus 3 here. Half and half you can take common. This will be ln t plus 1 minus ln t plus 3. So it will be log a minus log b. So this will be log a divided by b, that is ln a divided by b. So we have ln t plus 1 divided by t plus 3 with a modulus plus a constant of integration. Now if you remember, t was taken as x square or assumed to be x square. So now replace t by the original thing which was given in the question, which is x square. So half ln x square plus 1 divided by x square plus 3 plus a constant of integration, and this will be your final result. Now this is how we are going to do this. This is quite an easy question. The only trick is x square equals to t has to be put in to make it easier in order to formulate it in the form of integration of partial fractions. Putting then all these you have to write. Logic is clear to you. Integration of 1 by x log x and 2 plus log x. Now in first view it seems what do we do with this log x? But if you take this log x and try to convert this integration in a formal in partial fraction way, it will be quite easier. That is, if you take t equals to log x or replace t with log x, this dt by dx will be equal to 1 by x. So this dt became dx by x, and you see in the question dx by x is already given to us. It's already there. So integration will be equal to, in place of dt or in place of dx by x, write dt. What else is remaining? Log x we have already taken as log x and t, and 2 plus log x means 2 plus t. So we need to find out the partial fraction. It will be quite easier because 1 by t and 2 plus t is straightforward. We don't have to worry about the order of numerator and denominator. It's the denominator has higher order. So you can have a divided by 2, t plus b divided by t plus 2. So we are actually finding capital A and capital B. So take the LCM on the right hand side, a multiplied by t plus 2 here and then b multiplied by t here. Denominator will give you t into t plus 2. Now this denominator gets cancelled. You have a and you have b. For that, first in order to find out these two, t equals to negative 2 first we'll put. So the first term on the right hand side will become 0. Only b will come. From here to here it will vanish. It will go. So 1 equals b multiplied by negative 2. From this b is negative half. Now this is done. Coming to the second constant, if you put t equals to 0, the second term of the first equation will become 0. So now place t equals to 0 everywhere on the left hand side and right hand side. A became 1 by 2. Now what we are going to do here is, we are going to write it as partial fractions. So how did we write it? A divided by t and then b divided by t plus 2 or t plus 2 to 2 plus t. Now when we integrate this, we'll replace a and b by half and negative half respectively. So I'm taking this half outside. If you want, you can take, because half and half can be taken outside. Only this a by t and b by 2 plus t will remain. So integration of dt by t in one case, followed by integration of dt by 2 plus t or t plus 2 in another case. So when you take this half outside, so let's take it outside. dt by t will be simply ln modulus of t, and this will be dt by t plus 2 will be ln modulus of t plus 2. So log a minus log b will come, and log a minus log b is simply log a by b. So log a minus log b, it's log t minus log t by 2. So it will be ln t divided by t plus 2 inside the modulus sign. Modulus sign is necessary plus a constant of integration. Now I'm just writing here because I just want to complete this in this screen only. Half ln modulus of, now t was taken initially, remember, it was log x. So replace t by log x now. The log x divided by log x plus 2 and plus a constant of integration. This is your integration I. Alright, so this is the result I was talking about. There is just one thing, if you are able to understand that log x can be placed as t, other things are quite obvious and will be easier for you. Alright, now here we have x square plus x plus 1, and in the denominator we have x square plus 1 and x plus 1. So the power in the numerator or the order of the numerator is 2 and denominator is 3, but you have a quadratic equation in the denominator, x square plus 1, which is in the denominator. This x square 1, we need to try some other thing here, which I explained you earlier also in the beginning of this discussion of this chapter. So x square plus x plus 1 divided by x square plus 1 into x plus 2. Now this can be written, we are just talking about partial fraction right now, I'm not integrating right now. So this will be a divided by x plus 2, because x plus 2 is a simple linear equation. So we can have a constant, one constant upstairs, but x square plus 1 is not a linear equation. It is actually a quadratic equation, because x square minus 1, if you remember, it can be replaced by x minus 1 into x plus 1. But x square plus 1 cannot be divided into factors. That's an issue. For that, because denominator has quadratic equation, we have to write bx plus c in the numerator, which will be above x square plus 1. Now let's take the LCM in order to find out this a, b and c capital. So a into x square plus 1 plus bx plus c into x plus 2, and in the denominator we are going to get x plus 2 into x square plus 1, and on the left hand side nothing is changed. We are just writing it so that we can say that what is the question and how we are going to form it. The denominator will get cancelled. We will equate now, that is, we'll equate the similar terms. For that you have to multiply a with x square plus 1, bx plus c with x plus 2. Left hand side x square plus x plus 1 only remains. On the right it will be a into x square plus a after multiplying these two, then bx plus c. So bx plus c multiplied by x, then bx plus c multiplied by 2. So bx square plus cx you can write, then bx into 2, 2bx, and then 2c. Now just combine or collect the similar terms. That means a plus b into x square. The first thing is this one, and a plus b into x square. Then we will go for the term with x. So the constant will be c plus 2b. This we have already used. Now a plus 2c. So there are three terms which we can equate. We have to equate the coefficients. So x square has a coefficient 1, x square has a coefficient a plus b on the left and right respectively. So a plus b will be equal to 1, c plus 2b with the same logic equals to 1, and a plus 2c same logic will become 1. So if you are able to solve these three equations, you will get a, b and c. So you can do it in any way. This is very simple for you, but I am trying to make it minimum effort taking. So I am writing a plus b below a plus 2c, subtracting these two, 2c minus b equals to 0. So 2c became equal to b, or you can write c equals to b by 2. Now c and b are together in the middle equation. Now you can replace here c by b by 2. 2b is already there. It's equal to 1. So this will be half plus 2 is it's 5 by 2. So you'll get b equals to 2 by this 5 by 2. 2 by 5 becomes when it goes on the right. Now you can put b here, to a plus 2 by 5 equals to 1. A will become 1 minus 2 by 5. It's 2 by 5. So 5 minus 2 by 5 is 3 by 5. So a become 3 by 5. Now coming to a plus 2c equals to 1. A is 3 by 5. It plus 2c is already what we have to find. So this c will be 1 by 5 in this case. Now a, b and c we have got. Now we are going to replace it here. A by 3 by 5, b by 2 by 5 and c by 1 by 5, and then we will separate them out and integrate them separately in three terms as three different partial fraction terms. So this I will become like this. 3 by 5 was a, if you remember. The remaining thing inside integration we can have dx divided by x plus 2. Now the second term has bx plus c. B was this 3 by 5 divided by x plus 2. This was the first term. The second term was bx plus c. So 2 by 5x plus 1 by 5 divided by x square plus 1. Now you need to separate the second term into two more terms. That is, I am writing this term right now. So we have 2 by 5 integration of x divided by x square plus 1 dx will always remain there. The second term will be 1 by 5 you can take outside, integration of this dx divided by x square plus 1. In middle term also just assume dx is already there. Now x plus 2, it's quite obvious that it will be log base e modulus of x plus 2. Call it as I1, I2 and I3. So 3 by 5 I1 plus 2 by 5 I2 plus 1 by 5 I3. This is the whole scenario which is unfolding. So 3 by 5 into ln modulus of x plus 2, which is very straightforward. This is 2 by 5 and this will be 1 by 5. Let's find out I2 and I3 separately. I2 will be equal to x divided by x square plus 1 dx. Now just put this x square plus 1 as u or some t. It's up to you, any constant you can use. So this dt by dx will give you twice of x. So dt will be equal to 2x dx. That is, if you want to have x dx, it will be equated to dt by 2. So this x dx will be dt by 2. Half you can take outside. X square plus 1 has been taken as t. So this will be simply log modulus of t. Half log modulus of t plus constant of integration. Now this will be half log, what was t? It was x square plus 1 plus constant of integration. So we have 2 by 5 here. So 2 by 5 into 1 by 2, then ln modulus of x square plus 1. So this is I3 now. Let's find out I3. It's dx by x square plus 1. Now let me tell you, it has a direct result. But even if you want the same procedure which we have done for x square by x square plus 1, and please remember, you cannot just do the like dx by x plus 2 was ln x by x plus 2. So this dx by x square plus 1 will not be directly ln modulus of x square plus 1. Alright, because we need to have a linear equation, and that also linear equation will be differentiated and the value will be divided. But here, this dx by x square plus 1, if you put x square plus 1, you will get something. But I have a better idea. Just let me do this first. You will see that we'll come to the same juncture. So where we are going to get x from here? We'll not get x. But after previous discussions of differentiation and integration, we already know that x square plus a square has a direct result. So integration of dx divided by x square plus a square, let me write it in a formal way. It will be equal to, if a equals to 1, it will be simply tan inverse x by a. So tan inverse x by a, x is what? It's x. A is what? 1. So it will be tan inverse x. So add a constant of integration if you want to all of this. This is 1 by 5 tan inverse x plus a constant of integration. So the formal result or the final result will be after cancellation of this 2 and 2 in the middle term. So let me write it formally. So this integration has come x square plus x plus 1 divided by x square plus 1 into x plus 2. This has become 3 divided by 5 log modulus of x plus 2. Now log base e it is. So you can always write ln in this case. So it will be 1 by 5 to the 2 got cancelled if you remember. Log modulus of x square plus 1 and then 1 by 5 tan inverse x. So this slight change here, it is x square plus 1. So this is how you can go about it. I explained you already. Now ax square plus bx plus c divided by x minus a into x minus b into x minus c. So this is a proper quadratic equation in the numerator, and x minus a, x minus b, x minus c in the denominator, and if you multiply them, the order will be 3. So the order of the denominator is higher than the order of the numerator. So we can have separate constant in here. That is, you can always write this as a divided by x minus a plus b divided by x minus b plus c divided by x minus c. Now we can take the LCM. So a will be, you just write the denominator, it will be easier for you. So when we write the denominator, it will be multiplication of x minus a and x minus b and x minus c. So this a will get multiplied, or a will have x minus b and x minus c plus b, x minus a and x minus c, and then c will have x minus a multiplied by x minus b. Now this is equivalent to the original one, which is ax square plus bx plus c divided by 3 factors, namely x minus a and x minus b and x minus 3 multiplied in the denominator. Now these 3 gets cancelled, so we can just regard this whatever is there in the numerator as equation number 1. Now we need to multiply these, or you can do one thing. If you put x equals to b, then the first term on the left hand side and the third term will vanish. Only the middle term will remain. And this b has to be on both the sides. You have to replace it on both the sides. So when we place x equals to b, the first and the third term I'm not writing because they will eventually be 0. And in middle one, x minus a is b minus a and x minus c is b minus c. This becomes equals to a into b square plus b into b plus c. So b became from this equation ab square plus c divided by 2 factors, which is b minus a into b minus c. So in the same way, we will find out the value of a and c also. When we place this x equals to a, what are we going to get? Now I'm writing x equals to a here. A into a minus b into a minus c will be equal to a into a square plus b into a plus c. Now this will give you what? A into a minus b, a minus c equals to a cube and ba plus c. So a has come like this: a cube plus ab plus c divided by a minus b into a minus c. Now let me just find out c also here, because it will be in the same frame then. X equals to c. Now when you put x equals to c, the first term and the second term will become 0, they will disappear. So c into c minus a into c minus b can be equated to ac square plus bc plus c. So c has become ac square plus bc plus c divided by c minus a into c minus b. So abc we have known now. Put it here abc, and then just because these are constant, we can then just separate them out or keep it out of the integral sign, and we can just integrate 1 by x minus a, 1 by x minus b, 1 by x minus c in terms of dx. So if you assume that this constant is k, for example, so k will be taken outside, integration of dx by x minus b will only be done. So this integration will be like this. A was, if you remember, a cube plus ab plus c divided by a minus b into a minus c. What is being integrated? Whatever is inside, this will be dx divided by x minus a. Now coming to the other one, which is ab square plus b square plus c divided by b minus a into b minus c. And what is being integrated? Dx divided by x minus b. Similarly, the third one, which is x minus c, will be done in the same fashion after writing capital C, which we found out in earlier discussion. So ac square plus bc plus c divided by c minus a into c minus b, integration of dx divided by x minus c. Let me write the final answer now. So this will be ln modulus of x minus a, this will be ln modulus of x minus b, and the third one will be ln is basically log base c, so ln modulus of x minus c. So I am writing the final answer. There is nothing to take common because this is quite cumbersome, or the different results. So we are not getting anything common. Even if you take a minus b or b minus a minus c and c minus b outside, there will be a lot of complication of negative sign, and then there will be certain things which we don't want because this is already quite simple. So we have a cube plus ab plus c divided by a minus b into a minus c ln modulus of x minus a, and then we have ab square plus b square plus c divided by b minus a into b minus c, and then we have ln modulus of x minus b, and the final time I am writing ac square plus bc plus c divided by c minus a into c minus b, and ln modulus of x minus c plus constant of integration. Now c is already there, so let's just change it. Let me write some k, or you can always write some p, which is a constant which always will come after indefinite integral. Now this will be the result, or this is the reference which you can follow. So only this is a standard result of the other question or the question which are going to be followed. Now this question, we have done a question like this. So the main thing here is this x divided by x square plus 1 multiplied by x minus 1. Now the x minus 1 can be having a capital A or a constant in the numerator, but when it comes to a quadratic equation, that is x square plus 1, bx plus c should be in the numerator. That is how we try to formulate this in the partial fraction. So let me show you, because this question has already been done, almost a question like this. So if you have any problem, just let me know. Now this question, this is also a very straightforward question, but we'll do it just to revisit all the concepts which we have discussed earlier. So just one thing, that if you are able to divide this into partial fraction, it will be easier Very easy. This 1 divided by the denominator, we have 3 factors. So 3 factors will have 3 constant on the right. So a and then divided by x minus 1. Then we have b divided by x plus 1 and c divided by x plus 2. So this x minus 1, x plus 1, x plus 2 can be anywhere in the denominator. This will form like this. The denominator will be x minus 1 into x plus 1 into x plus 2. Now left hand side remains the same. This is the actual integration material, but we are trying to divide this into partial fractions. So when we write a, anything except x minus 1, that is x plus 1 and x plus 2 will come. With b, with capital B, anything except x plus 1, that is x minus 1 into x plus 2 will be multiplied. With c, x minus 1 and x plus 1 will be multiplied. Now this denominator get cancelled. Now whatever is remaining, just call it as equation number 1. So in order to find a, we'll put x equals to 1, that will make the second and third term as 0. So on left there is no x, so just write 1, and on the right replace x by 1. So a into 1 plus 1 and 1 plus 2. So 1 equals to a, 2 into 3. So this a will be 1 by 6. So you can write 1 by 6 here, integration of this one. Now coming to b. So first and third term needs to be 0. For that we'll put x equals to negative 1. So only the term with b will remain. First and third will be 0. Left will be 1. Now putting x equals to negative 1 here, we'll get b into negative 2 and 2 minus 1 is 1. So this is equal to 1. So b becomes equal to negative 1 by 2. b equals to negative half. Now we need c. So we'll place x equals to negative 2 so that the first and second term becomes 0. So 1 will be equal to c into minus 2 minus 1 and minus 2 plus 1. So this 1 will be equal to c into minus 3 multiplied by negative 1. C became 1 by 3. So 1 is, this a is 1 by 6, b is negative half and c is 1 by 3. That's what we are going to put or replace it here. So the integration will be of this sort. 1 by 6 outside. Integration of dx divided by x minus 1 minus half. Integration of dx divided by x plus 1. This is 1 by 3 plus 1 by 3. Integration of dx divided by x plus 2. So 1 by 6 ln modulus of x minus 1 minus half ln modulus of x plus 1 plus 1 by 3 ln modulus of x plus 2. Since we have this 2 3s are 6, so it's the denominator constants are related. So better is to take 1 by 6 outside, that is constant. When you take 1 by 6 constant, what will be remaining inside? The first term will have ln modulus of x minus 1. This will be the first term. Here it will be 3. 3 will come in the numerator. So we have minus 3 ln modulus of x plus 1. Then you have 3. So 2 will come here. 2 ln modulus of x plus 2. Now there are certain relations of log. A log b is equal to log b raise a. So this 3 and this 2 power will go over this x plus 1 and x plus 2. Now log a minus log b plus log c kind of thing has appeared, and now we will do this log a plus log b equals to log a into b, and then we'll use log a minus log b equals to log a divided by b. First you can just add the first and last one, and then you can subtract. This way you can go about. So x minus 1 into x plus 2 whole square, which is the first and the third term, and the subtraction will go in the denominator. Let me write this also formally, that log a minus log b will be equal to log a divided by b. So ln is log base e only, x minus 1 into x plus 2 whole square divided by x plus 1 whole cube. This is 1 by 6. This is your I. Okay. So this is how we are going to go about it. Alright. So there are 60-70 questions in this exercise. Okay. So there will be certain questions we will skip. Those we have already done, or those kind of questions which have duplicacy. So this is all what you have to do here. And this all putting let, all this you have to write. The logic which I say, you have to add this storyline like language. Now when this question is first encountered, it seems like too many x squares are there. But if you see that just one replacement on one assumption will make this question very easy. What I am suggesting here is x square divided by x square plus 4. Now when you will make it as a partial fraction, you ought to have ax plus b. What does it mean? You need a linear equation over a quadratic equation. You cannot have a constant over a quadratic equation. Alright. Similarly, with the same logic, x square plus 9 is also there in the denominator. For that, you cannot have a constant. You have to have a linear equation. So cx plus d will be over x square plus 9. So the right side you have to take the LCM. Ax plus b will be multiplied by x square plus 9. X square plus 9, and then we have to multiply this cx plus d with x square plus 4. So x square plus 4 multiplied by cx plus d. The denominator will have x square plus 4 multiplied by x square plus 9. Now on the left, it will be x square divided by x square plus 4 x square plus 9. So this denominator you can cancel. Now we can equate these similar terms on left hand side and right hand side. It means that we need to find out A, B, C, D. And since there are 4 variables, then we need 4 equations. So now multiply. Ax into x square is ax cube. B into x square is bx square. Then ax into 9 is 9ax. Here is a slight mistake. I have written bx square. So this I will just replace just now as 9ax plus 9b. Now x square into cx will be x square cx. X square into d will be x square d. 4 into cx will be 4cx. Now x square d and then 4d. Now collect the term with x cube, collect the term with x square, then x, then constant. So one is ax cube. If you remember, x square was also multiplied by cx, so cx cube it is. So now just combine these two, ax cube and cx cube. So a plus c into x cube will be this first term. Then we have bx square. So bx square and dx square, that will be one term. So this bx square let me cancel and let me write 9ax, which was earlier by mistake not being written. So I'm just correcting it. So b plus d into x square, these two. Then coming to the x term, 9ax plus 4cx. So 9 capital A plus 4 capital C into x. Please remember, a and b are the constant we need to find out. But as a variable, we'll have 4 equations. Now constant will be 9b plus 4d. Now if you compare it with the left hand side, only one value, which is b plus d x square, will be equal to x square. That is b plus d will be equal to 1. There is no other similar term on the left hand side. So every other thing will be 0. So a plus c will be 0. A will be equal to negative c. B plus D only will be 1 because there is only x square term on the left hand side. Now 9a plus 4c will be equal to 0 and 9b plus 4d, this will be equal to 0. So we have 4 equations here. If you place this a equals to negative c in the third equation, so we have minus 9c plus 4c equals 0. So c will be equal to 0. A equal to 0, that's why c equals to 0. Now we will solve this b plus d equals 1 along with 9b plus 4d equals to 0. So multiply this equation b plus d equals to 1 with 4. So it will be 4b plus 4d equals to 4. And then we subtract. This 4d minus 4d will get cancelled. 9b minus 4b will be 5b. On the right, it will be 0 minus 4. So this will be negative 4. So b becomes equal to negative 4 by 5. Now put it here. Negative 4 by 5 plus d equals 1. So d will be equal to 1 plus 4 by 5. It will be 9 by 5. Now a equals to 0, c equals to 0, d 9 by 5 and b equals negative 4 by 5. Now let's integrate. This integration will be, because we have already found out a, b, c, d. So a and c is 0. So the values which have x as the variable along with them, they will be 0. Only constant will come. So we have b, which is negative 4 by 5 divided by x square plus 4, and then d. So 9 by 5 was d and x square plus 9 was in the denominator. This is integrable, or we can form two partial fractions. Negative 4 by 5 integration of x square plus 4 is our first term. So x square plus 2 square you can write. A square plus x square or x square plus a square. We'll write the direct formula, which is tan inverse x by a. I'll just show you. 9 by 5 integration of 1 by x square plus 3 square. So integration of this dx divided by x square plus a square is 1 by a tan inverse x by a. Alright, the formula is 1 by a tan inverse x by a, remember. So what will come here? Tan inverse x by 2 and 1 by 2 will also come. I'll just write 9 by 5 tan inverse x by 3. So 1 by a also will come, 1 by 3 will also come. So please remember there is a slight change in this formula. Integration of dx by x square plus a square is tan inverse x by a. So let me include this. So 1 by 2 and by 3 because of 1 by a tan inverse x by a, that will come. So let me write the final answer, minus 2 by 5 tan inverse x by 2 plus 3 is 9. So 3 divided by 5 tan inverse x by 3 plus constant of integration. This is your final result. Now this is the way it will be done. Just remember this x square plus 4 is quadratic. So you ought to have ax plus b in the numerator. There are two quadratic equations. So you have this one. Two linear in the numerators. Now this question is quite easy. There is no trick, no special thing which needs to be explained or told to you guys. 5x square minus 1. You have the order of 2 in the numerator and order of 3 in the denominator. Just write a divided by x, b divided by x minus 1 and c divided by x plus 1. And then you can integrate this quite easily. This is your final answer. I hope you will be able to do this. X square plus 6x minus 8. Division is x cube minus 4x. Now the question which will come into your mind is what we will do with x square minus 4x in the denominator. So x, if you take common, x square minus 4 will remain inside. X square minus 4, that is x square minus 2 square, will be x minus 2 into x plus 2. So this a square minus b square is a minus b into a plus b. That's what we are going to use here. X square minus 4 can be written as x square minus 2 square, which in turn will become x minus 2 and x plus 2. So this denominator can be changed to x into x minus 2 and x plus 2. Now this is a very solid ground to integrate this using the partial fraction. So you can have a, b, c because there are three factors, three linear equations in the denominator. A by x plus b by x minus 2 plus c by x plus 2. And a, b, c can be computed with x square plus 6x minus 8 on the left hand side. And then integrate, a log will come in these three. The basic thing is this question is to write x square minus 4x in the form which I just told you, x into x minus 2 and into x plus 2. So it's a very basic question, and one thing if you do, that you'll be able to do because already 19 questions we have covered. X square plus 1, 2x plus 1 and x square minus 1. Here also we have 2x plus 1 which is a linear equation, but x square minus 1 can be written as x square minus 1 square, which in turn can be written as x plus 1 into x minus 1. So we have a divided by 2x plus 1, b divided by x minus 1 and c divided by x plus 1. That is 3 values or 3 parts can be integrated easily if you find out ABC. So this is how you have to go about it. It's again a very straightforward question, and we have already done a question like this. Now this question also has very straight statement to be made, because only log x if you put as t, all these things will become easy. I am trying to suggest that this question needs log x to be placed as t or some variable. So dt by dx will be equal to 1 by x. dt will come as dx by x. So dx by x is dt. So this integration will come like this. 1 divided by, after replacement of log x as t. So this will be 6t square plus 7t plus 2. And this dx by x will be replaced by dt. So this dt, this is integration. So eventually you have to integrate this denominator, which is 6t square plus 7t plus 2. And this can be written in the form of factors. It will be 3t plus 4t. So 6t square added with 3t and then 4t along plus 2. Now take this 3t outside. You will get t plus 2t plus 1. Then you can take 2 outside, again 2t plus 1 will come. So the factors will be 3t plus 2 and 2t plus 1. So when we take the partial fraction, it will be 1 divided by 6t square plus 7t plus 2 can be written as 3t plus 2 multiplied by 2t plus 1. On the right, because we have on the left 2 factors, we will have 2 constant on the right. So a divided by 3t plus 1 and b divided by 2t plus 1. Let's take the partial fractions here. In order to do that, we have to cross multiply. A multiplied by 2t plus 1 plus b multiplied by 3t plus 2, and this will be divided by 3t plus 2 multiplied by 2t plus 1. On the left hand side, it will be 3t plus 2 multiplied by 2t plus 1. Just cancel these two. Equation number 1, call it as. So what to put? When 2t plus 1 is equal to 0, t will be negative half. This you will put. 3t plus 2 equals to 0, that means t you have to put as negative 2 by 3. So once we will put t equals to negative half, the other time we'll put t equals to negative 2 by 3. So when we put t equals to negative half, first term on the right will become 0. Only b term will come, b into 3 into negative half plus 2 equals to 1. So this is essentially 2 minus 3 by 2. So 4 minus 3 by 2 will come. Now b has become 2 because t2 will go upstairs. Now put t equals to negative 2 by 3. And this will give you 1 equals a into 2 into negative 2 by 3 plus 1. This is simply 1 minus 4 by 3. So negative 1 by 3 will come and 3 will go on the left with a negative sign. So a has become minus 3 here. We'll use b equals to 2 and a equals to negative 3. So this is how it will be integrated after placing a and b respectively. So this integration will be integration of minus 3 dt divided by 3t plus 2 integration of dt divided by 2t plus 1. Integration of 1 by x will be log modulus of x. dx by x is log x. And then we have to differentiate 3t plus 2. So 3 will come, that will come in the denominator. So integration of dt by 3t plus 2 will be 3t plus 2. But after this 3t plus 2 will be differentiated, that forms 3, that will come in the denominator. Similarly, in the case of 2t plus 1, it will be 2 ln modulus of 2t plus 1, that is 2 log modulus of 2t plus 1. 2t plus 1 will be differentiated, 2 will come, that will go in the denominator. So just cancel these, 3 also gets cancelled. I am writing the second term first. That's why ln modulus of 2t plus 1 minus ln modulus of 3t plus 2. And log a minus log b will be equal to log a divided by b. This will be ln 2t plus 1 divided by 3t plus 2, this inside the modulus sign plus a constant of integration. Now initially, if you remember, we took t as log x. Now this is the time for replacement. Log base e or ln, in place of t, replace it by log x. So 2 log x plus 1 will come, 2 log x plus 1. In the denominator it will be 3 log x plus 2 plus a constant of integration. This is your final answer. Now this is how this will be done. The only thing is dx by x will be achieved only when you put log x equals to t. Now this question, 1 divided by x into x raised n plus 1. Now this x raised n is very important because we have to take t equals to x raised n. dt by dx will be what? nx to the power n minus 1. That means x to the power n minus 1, if you want to write, multiply it with dx here and then dt divided by n. That means we need x raised n minus 1 in the numerator. For that, multiply numerator and denominator by x raised n minus 1. So x to the power n minus 1 will be multiplied by numerator and denominator. The rest other things remains the same, x into x raised n plus 1. So the numerator x raised n minus 1 dx we already got after putting t equals to x raised n and differentiating it. So this can be written directly as dt by n. So let's write dt 1 by n here. How about this x raised n plus 1? If it is t x raised n, then it will be t plus 1. Now x into x raised n minus 1. So when you add this x raised 1 plus n minus 1, 1 gets cancelled. So this will be x raised n only. So this is 1. So we get x raised n. And this was already taken as t. So now the question has become very easy. We have to just take the partial fraction of 1 by t and 1 by t plus 1. I am not integrating right now. Just trying to find out the a by t plus b by t plus 1, which is the partial fraction which we are going to integrate eventually. So now cross multiply a into t plus 1 plus b into t divided by t into t plus 1. 1 divided by t into t plus 1 here. Now cancel this. So this is equation number 1. Now when you put t equals to 0, this will disappear, b into t term. So 1 will be equal to a. Now put t equals to 0. A becomes t. Now when we place t equals to negative 1, this whole part will be 0 first term. So the second term will be b into negative 1 will be equal to 1. So b becomes equal to negative 1. Now this equation, if you use this, now we are formally integrating it. So 1 divided by t. Now when we integrate, this 1 by n is already there outside. dt by t for this a by t, because a is just 1, and this b is negative, so I am writing negative b is 1 only. So let's eliminate this. So dt divided by t plus 1 has to be integrated. Now if this is I, this will be log modulus of t, this will be log modulus of t plus 1. And what is log a minus log b? It's log a divided by b. So log t divided by t plus 1 in modulus side. Now you have to write this t as what? X raised n was taken as 1 by n is already preceding. So let me write the final result here. So this I will be equal to 1 by n. Then we have ln or log base e. and the first one was t by t plus 1 ln. So write this t as x raised n, replace it by x raised n. So x raised n divided by 1 plus x raised n, modulus just close it, plus constant of integration. So this is a different kind of question because you have to multiply x raised n minus 1 numerator and denominator. Then only you are going to get it. And x raised n has to be placed as some t or something so that you can make this easier. So this is how it will be done. Whole process you might have understood. So it's a different kind of question that you can follow. This one is x raised minus a square and x square minus b square in the denominator. Now if you take this x square, the differentiation of x square will give us x dx. Of course, a 2 will be there. So let's take this in order to make it simpler. Take t equals to x squared. dt by dx will be equal to 2x. That means if you multiply this, so dt by 2 will be equal to x dx. And if you see here, x dx is already in the numerator. So this integral will be formed like this. After taking t equals to x squared, numerator x dx will be dt. 1 by 2 because dt by 2, and in place of x square write t. So t minus a square and t minus b square will come in the denominator. Now a square, b square are just constant, so don't get worried about that. So now we'll find out the partial fraction. It is just like x minus 1 and x minus 2 kind of thing. So 1 divided by t minus a square and then t minus b square. So this equals a divided by t minus a square, and then we have b divided by t minus b square. Now let's cross multiply. A multiplied by t minus b square, then b multiplied by t minus a square. So 1 divided by t minus a square into t minus b square here on the left. On the right also in the denominator you will get t minus a square into t minus b square. So denominator you can cancel them out and just assume that the numerator is equation number 1. 1 equals to a t minus b square plus b t minus a square is your equation. Now we need to find out a and b. So systematically we'll eliminate a and b. How to eliminate that? If you take a equals to 0, t minus b square should be 0, so t will be b square. With the same logic, t should be a square. So first we will take t equals to b square, and the first term will disappear, only 1 on the left, and b into t, in place of t I am writing b square. So b becomes 1 by b square minus a square. How about the second term? So t, if you put a square, this portion will be 0. So 1 becomes equal to a into a square minus b square. Now a will become 1 divided by a square minus b square. So a and b are almost similar with a negative sign. Means the difference only is the negative sign. We are going to utilize this negative sign. So this a will replace it by 1 by a square minus b square. In place of b, we'll write 1 by b square minus a square because they are constant, they'll come in front. We just have to integrate 1 by t minus a square and 1 by t minus b square. So 1 by a square minus b square, in place of a will come. Denominator will be t minus a square. We are going to integrate this. Half is already outside. We are going to put it in the end. Then the second one is 1 divided by b square minus a square. This is the numerator, which is b, and t minus b square in the denominator with a dt. Now this is a constant. You can take it outside. Here also 1 by b square minus a square is simply a constant. You can take it outside. And half is already there outside of everything. So this integration has become something like this. 1 by 2 we are going to deal just now. So dt divided by t minus a square. And I told you that a was this one. So I am writing this a1 outside the integral sign. So we'll integrate this one only. Now the second term is b square minus a square in the denominator. So if you take a negative, it will be a square minus b square. So this will form like this, 1 by a square minus b square. Integration of dt divided by t minus b square. So 1 by a square minus b square can be taken outside now because this is constant. This appears in both of the terms. 1 by 2 have also integrated, and dt by t minus a square is simply log modulus of t minus a square. Then you have a negative sign, again ln or log base c, modulus of t minus b square. This log a minus log b is what? Log a by b. So log base e or ln a by b is t minus a square divided by t minus b square. So log this reality of log you already know. So log t minus a square by t minus b square will be formed plus a constant of integration. So 1 by 2 a square minus b square. Now initially t was taken as what? Remember, t was x square. Now just replace this and the final answer will come. So 1 by 2 a square minus b square, then log base c. You cannot write it as log or ln x square minus a square divided by x square minus b square in a modular sign plus a constant of integration. This is your final answer. Now this is how it has to be done. So I hope you have got a better idea of this and you'll be able to solve this. Now this one is x square plus 1 divided by x square plus 4 and x square plus 25 in the denominator. Now you already know how to do this. You know how? You have x square plus 1, which is the quadratic in the numerator. But the denominator x square plus 4 is again a quadratic equation. When you multiply this, the order of numerator is 2, denominator is 4. So whenever you have a quadratic equation, x square plus 4 is a quadratic equation. So you cannot have a constant here. You ought to have a ax plus b or a linear equation containing some constant which are a and b here. So x square plus 4 has ax plus b on the top. Similarly, with the same logic, x square plus 25, which is a quadratic equation, we have cx plus d in the numerator. So x square plus 25, cx plus d on the numerator. Now just take the LCM, find out a, b, c, d. You already know that. This kind of questions we have already covered, and then you can solve it. So this is how this is going to be solved. It's very straightforward. Only this one thing which I wanted to highlight. Now in this question, it's not a proper rational function. Kaise? Numerator has an order of 3. Denominator has an order of 2. So the order of numerator is higher than order of denominator. First you have to make it as a proper rational function. For that you need to divide this. That is, you have to minimize the numerator power order. So x square minus 1 here, x cube plus x plus 1 here. Now you have to multiply x square with x in order to get x cube. So x cube, then minus x. Now subtract this. So x cube will get cancelled. You have x plus 1 because there is nothing below 1. So it's actually 2x. X plus x is 2x. So 2x minus 1. Now there is no other thing which we can do. So we can write this in the form of divisor, dividend and quotient. How to do that? First we write x. Then we add, then 2x plus 1 will come and denominator will be x square minus 1. So this integration which is there, you have to integrate these two. X is quite easy, you know, integration of x is x square by 2. But 2x plus 1 divided by x square minus 1, we can write x square minus 1 as x minus 1 into x plus 1 because a square minus b square is a minus b into a plus b. Now I'm integrating them. Integration of x is straightforward, as you already know. It will be x square by 2. How about 2x plus 1 divided by x minus 1 into x plus 1? Call it as I1. So we need to find out the I1. Then we'll add x square plus 2 to that, and that will be the final result. So 2x plus 1 divided by x minus 1 into x plus 1. So when we take the partial fraction, a divided by x minus 1 or x plus 1 you can have. Either way you can change. X minus 1, x plus 1 can be below any of the constant. It's up to you. A into x minus 1 plus b into x plus 1 divided by x plus 1 into x minus 1. On the left it is 2x plus 1 divided by x minus 1 into x plus 1. Just cancel these two. This is your equation number 1. Now in order to get a, x should be negative 1 because the second term on the right will disappear. And in order to get b, you need x equals to 1 because the left or the a term will disappear. So let's take x equals to 1 on both the sides. So 2 into 1 plus 1 will be equal to b into 1 plus 1. So this will be 3 on the left and 2 on the right. So b becomes 3 by 2. Similarly, x, when we place it as negative 1, we will get 2 into negative 1 plus 1 on the left. And on the right, that will be a into negative 1, negative 1. So this will be negative 2 plus 1, that is negative 1. And on the right, it will be negative 2, a into negative 2. So a has become 1 by 2. Now let me write this equation again. When you put integration sign in front of this, in terms of dx. So a and b can be put in front of integration sign because they are constants. So we need to integrate only dx by x plus 1 and dx by x minus 1. So half I am taking outside. Dx by x plus 1, and that is 3 by 2 integration of dx by x minus 1. So we have x square by 2 already. If you remember, I1 was this one, but I was x square by 2 plus I1. So I1 I am now writing half. This will be log modulus of x plus 1, and this will be 3 by 2 log modulus of x minus 1 plus constant of integration. Now you can add certain thing in here also, but this is the final answer. But even if you want to add something like this, you can take common from log x plus 1 and 3 by 2 from here, that is half. If you take, only 3 will remain. So this will be log x minus 1, but you know that the power goes inside as x minus 1 cube. So this x square by 2 plus half you can take outside. This will be log a into b. So this will be log x plus 1 into x minus 1 whole cube, and inside a modulus plus constant of integration. This is your final result. So you could have finalized the penultimate equation, but this is also true. Now this is how you have to do it. This is not a proper rational function. That's why we divided it, and then we got a very easier version to integrate. For that we need to have a partial fraction that we did, and then eventually this integration was being done. And you can write in this way, or you can use the log property. It's up to you. Now we have integration of 3x minus 2 divided by x plus 1 whole square multiplied by x plus 3. Now many questions which are following of exactly this type. So you need to understand it very carefully. Now we have 3x minus 2. Normally people would think that this x plus 1 whole square can be written as x plus 1 into x plus 1. We have x plus 3 also here. So this can be easily written as, in normal sense, we have 3a, b, c as the constants. X plus 1, then x plus 1 and x plus 3 in the denominator. This is the way to do it, but this is not the correct way because x plus 1 whole square is a quadratic equation. This is a wrong approach. What is the correct approach? So let's call it as I, and then we are going to convert it into the partial fraction form. So this 3x minus 2 divided by x plus 1 whole square and x plus 3 in the denominator. This will be written like this. This is the core of these questions and the questions following. This will be A, then we have B. A will have x plus 1 in the denominator, B will have x plus 1 whole square in the denominator, and then we have C, which is C divided by x plus 3. So this is how this kind of question will be approached. Now take the LCM. So we have A along with, let's take the LCM first. So we have x plus 1 whole square multiplied by x plus 3. With A, x plus 1 will come and x plus 3 will be there. With B, x plus 1 square is already there. So C, with B it will be x plus 3. And then along with C, it will be x plus 1 whole square. On the left, it will be 3x minus 2 divided by x plus 1 whole square and x plus 3. Denominator you can cancel. So this equation I am writing again. 3x minus 2 will be equal to A into x plus 1 into x plus 3 plus B into x plus 3 and plus C into x plus 1 whole square. Now, if you put, as in previous 26 questions we have done, if you put x equals to negative 1, this will disappear, this will disappear, B you will get. But when you put x equals to negative 3, this will vanish and this will vanish, C you will get. How about A? From where are we going to get A? That's an issue. So we need to multiply this word and then we will equate these similar terms coefficient. So multiplying x plus 1 and x plus 3, it will give you x square plus 4x plus 3. So A multiplied by this one. Then we have bx plus 3b. X plus 1 whole square is x square plus 1 plus 2x. So multiply it with c. So cx square plus c plus 2cx. So when you multiply inside, ax square plus 4ax plus 3a plus bx plus 3b, and then cx square plus c plus 2cx. So on the left we have no x square terms, so 0x square, 3x and negative 2. Now let's compare. So we have a plus c with x square. This we have used. Then we have 4a plus b, this plus 2c. This is the x term, and then the constant. So we have 3a plus c. So there is a slight change, 3b will also come. Now 0x square plus 3x minus 2. Now let's equate. So a plus c will be equal to 0. 4a plus b plus 2c. So this will be equal to, on the left you see 3. And 3a plus c plus 3b will be equal to negative 2. Now take a equals to minus c. Put it in the other two equations. There will be b and c, and solve those equations. I hope you will be able to solve this. This is very simple linear equation solving. So now we have a, b and c. I hope that you have computed that. So the partial fraction will be something like this. A will come as 11 by 4. B will be negative 5 by 2 and C will be negative 11 by 4. So A divided by x plus 1 whole square. Oh no, x plus 1. The next will be x plus 1 whole square. And then minus, because negative 5 by 2 has come in place of b, negative 5 by 2 divided by x plus 1 whole square. And then we have c, which is negative 11 by 4 divided by x plus 3. Now I'll take this outside. If we are integrating this constant can be taken out. We will integrating dx divided by x plus 1. Then minus 5 by 2 here. Integration of 1 by x plus 1 whole square dx minus 11 by 4. Integration of dx divided by x plus 3. So this 11 by 4, I'm writing first and the third together. That means we'll take the third one later. So 11 by 4 log x plus 1 minus 11 by 4 log x plus 3. Don't combine them. Means log a minus log b formula don't combine, because 11 by 4 can be taken outside and you'll be tempted to do a log a minus log b. But 1 by x plus 1 whole square integration is negative 1 by x plus 1. How will it come? See, x plus 1 whole square goes up, negative 2 x to the power n plus 1 divided by n plus 1 is the integration. So you'll get x plus 1 to the power negative 1 divided by negative 1. So minus 1 by x plus 1 will come. So make it as positive because negative 1 by x plus 1 will come. Pi by 2 remains here, 1 by x plus 1. So this is your final result. This is the integral final result. Alright. Add a constant integration also. So this was a different kind of questions, but if you have understood this question, the later questions are like this only. So 2x plus 1 divided by x plus 2x minus 3 whole square. How are we going to write this? Let me tell you, because this is the core how to write this. So we can write it like this: a divided by x plus 2, then we have b divided by x minus 3 and plus c divided by x minus 3 whole square. So this is how it will be done. Alright, the equation solving is the key. Again, this is the same one as the 27th and 28th question. So I hope you have understood the 27th question, and this is the way you can solve it. Again, it's more easier than the previous ones. It just has x in the numerator. Again, straightforward question. You can try it by yourself. Same here, so you can do it. Let me tell you, there are 60 to 70 questions in this exercise. So if we don't pass certain questions, it will take whole life. Just exaggerating. Okay, now this again has the same steps to be followed as we discussed. Don't worry, we are not going to leave all of them. Anything which needs explanation, we are going to discuss that. And this question, now this seems to be a different kind of questions, but let me write it. How to write this? The integration will be something like this. We have 2x square plus 7x minus 3 divided by x square. This x square is the main key here. 2x plus 1 you already know how to write in the partial fraction form. So a divided by x plus b divided by x squared. A divided by x plus b divided by x squared plus c divided by 2x plus 1. Now again 60-70 questions, so we have to skip certain question. Now this question, now it seems to be different, but with certain simple steps you will see that it will look like as if you have already done it. Let's see the denominator. This is x cube plus 2x square plus x. You can take x outside, so we have x square plus 2x plus 1. Now this x square plus 2x plus 1 is simply x plus 1 whole square. That is x into x plus 1 whole square it is. From here to here, this 5x square plus 20x plus 6 divided by x cube plus 2x square plus x. And this will be written like this. So a divided by x plus b divided by x plus 1 and then c divided by x plus 1 whole square. Take the LCM now. X and x plus 1 whole square will come. Now with a, x plus 1 whole square. Then we have b, so x and x plus 1 will come. And then with c, x will come. On the left, we have already converted it into x plus 1 whole square. So you can write it like this. So 5x square plus 20x plus 6 divided by x into x plus 1 whole square. You can cancel the denominator. Please remember, x equals to -1 and x equals to 0. You can solve it like this, but you will be left with the same procedure which has to be adopted later. That is, you have to multiply everything and compare the left and right similar terms. It means that a x plus 1 whole square is, we have already seen that x square plus 2x plus 1 is x plus 1 whole square. So write it like this. B x into x plus 1 will be x square plus x. So bx square plus bx will come. Then we have cx. So multiply this, ax square plus 2ax plus a plus bx square plus bx plus cx. Now combine the similar terms. That is with a similar order. So a plus b with x square. Then take the term with x. So 2a plus b plus c will come. X plus a. Constant is only a. Now it will make it very easy because constant is just one term. So when you compare it with 5x square plus 20x plus 6, all the coefficients, that is 5, 20 and 6, a has come as 6. Now take this a, put it in the first equation, a plus b equals to 5. Second equation will be 2a plus b plus c equals to 20. A is already 6. So 6 plus b equals to 5. B you will get as -1. Now put it here. 2 into 5, 2 into 6 minus 1 plus c equals to 20. So 6 to the 12. 12 and minus 1, that is 11, and it goes there. 20 minus 11 is 9. So c has come as 9. Now we'll put in place of a 6, then we'll integrate. In place of b, we'll put negative 1, integrate. In place of c, we'll write 9, integrate. This all along with dx. So let's do it formally. So integration will come like this. 6 integration of dx by x. Negative 1 was there, so minus dx by x plus 1, and then c came to be 9, so 9 integration of dx by x plus 1 whole square. Integration of x plus 1 whole square in the denominator is negative 1 by x plus 1, which we have done in the question number 27 or the earlier question. It's just will be done with integration of dx by x square form. So 6 log modulus of x, log base e, you can call it as ln or log base e. So 6 log x minus log modulus of x plus 1, and then we have a negative 9 and x plus 1 whole square integrated, which will form negative 1 by x plus 1, which we have already written. Now if you want to do that log x raised 6, then log a minus log b, you can do that, but it's not required here. So just see it here and witness and notice that we have done the same thing, just one trick, that is putting x cube plus 2x square plus x as x into x plus 1 whole square, which is the whole important key of this question. Now this seems to be a typical question, but I'll just write how you have to proceed. 18 divided by x plus 2, that is x plus 2 will be regarded as a divided by x plus 2. Then x square plus 4, x square plus 4 will be bx plus c. So you have to have a quadratic equation in the denominator. For that you need bx plus c in the numerator, and then find out abc and then put it and integrate it. Now let me show you how it will be done. Any question of different form, we will definitely do it. Now this I leave it to you. It's also equating or is similar to the previous questions. The same here, it's easier than the previous one. I hope that this is clear to you. If not, you need to revisit the questions we have already attempted and solved. So this is the 1 by 1 plus x plus x square plus x cube. Now this seems to be a typical question, different question, but you will see with one trick or one proper arrangement, you can easily solve it. So this is dx by x plus 1 into x square plus 1. We have already done this question, or I have showed you the reference of this. So this will be done like this: a by x plus 1 and bx plus c by x square plus 1. This I already told you. Now why I am telling you this, you will be asking that this question is different. Why are you telling me all this? You will see just now. This question will ultimately boil down to this kind of equation only, or this kind of integration only. So 1 plus x is already there. I am taking the denominator. Take the x square out of x square plus x cube. So 1 plus x will remain. So 1 plus x, if you take outside, 1 plus x square will be there. Now what do you see? 1 plus x. Let me write the integral first. You will see the similarity. Integration of dx divided by 1 plus x into 1 plus x square you can write, or you can write x plus 1 into x square plus 1. Whichever way you write, the approach remains the same. So is it matching? Yes. Of course it's matching. So it's x plus 1, x square plus 1, and I already told you how to write it. A divided by x plus 1 plus bx plus c divided by x square plus 1. So this is how you are going to go about it if you find any problem. Now this question, there are two things which we are going to use. Both of them we have already seen. So first we'll devise it in the form of a partial fraction. So this 1 divided by x plus 1 whole square. So wherever we have a square or a linear term which has square, we'll have two constants. So one time we have x plus 1 in the denominator. Second time we have x plus 1 whole square in the denominator. So a divided by x plus 1 plus divided by x plus 1 whole square. Second one is a quadratic equation, which is x square plus 1. For that we need cx plus d, that is a linear equation above the quadratic equation x square plus 1. So what do we get from here? Let's take the LCM first. So we have x plus 1 whole square along with this x square plus 1. With a, what will come? We'll get x plus 1 and x square plus 1 along with a. Because x plus 1 whole square is already there, with b we'll get x square plus 1, and with cx plus d, x square plus 1 you can eliminate, or only x plus 1 whole square will come. Now on the left and the right, what do we have? Before cancelling the denominator, let's multiply these two, x plus 1 and x square plus 1. So we have x cube plus x square plus 1. This comes along with a. With b it will be bx square plus 1, and with cx plus d you have to expand this x plus 1 whole square. It will be x square plus 1 square plus 2x. a square plus b square plus 2ab. So now we need to multiply cx plus d with x square plus 1 plus 2x. First take cx, multiply it with x square plus 1 plus 2x. Then take d, multiply it with x square plus 1 plus 2x. So that is what I am doing right now. So finally we have ax cube plus ax square plus a plus bx square plus b plus cx cube plus cx plus 2cx square plus dx square plus d plus 2dx. So we have 1 on the left. This x square plus 1 and x plus 1 whole square will get cancelled. So on the left you will get what? We have 0x cube. There is no x cube on the left. There is no x square on the left. There is no x in the left. Only constant will be there. So now combine these similar term, that is all the term along with x cube. So a plus cx cube first will come. Then we have ax square and then bx square. So a plus b, with x square we have 2c. Then we have d, so x square. Now take the x term. So we have ax, cx and 2dx. So this will become a plus c plus 2d along with an x. Now take the constant a, b and d. So a plus b plus d. Now let's equate. A plus c will be equal to 0. A equals to negative c. A plus b plus 2c plus d. This will become 0. Then we have a plus c plus 2d. This equals to 0. But a plus b plus d will be equal to 1. Now there are 4 variables, 4 equations. I hope you'll be able to solve this. We have already completed in 8th and 9th standard before that also. So a will come as half, b will come again as half, c will be negative 1 by 2 and d will be 0. So in the original equation, let's put it. So it's half divided by x plus 1, then b divided by x plus 1 whole square. So half divided by x plus 1 whole square. C is negative half, so you can have a negative here, and negative half, it will be cx plus d. So negative half into x plus 0. So minus half x will come in the numerator, and in the denominator it will be x square plus 1. Now let's integrate. Half you can take outside, dx divided by x plus 1. Here also half, integration of dx divided by x plus 1 whole square. Here negative half and x divided by x dx actually divided by x square plus 1. Now this is quite clear. It will be log or ln, log modulus of x plus 1. This we have already done in the previous question. It is negative 1 by x plus 1. That is dx by x plus 1 whole square is directly negative 1 by x plus 1. You can directly replace it. So negative half is already there. Minus minus become plus. Next one is what? It's negative half x square plus 1. You can write it as t. dt by dx will be equal to 2x. dt by 2 will be dx dx. This will be dt by 2. You can take 2 outside. You have to integrate dt by t because t we have taken as x square plus 1. So log modulus t, half log modulus t. Half is already there, so half into half is 1 by 4, and log, this will be modulus of x square plus 1 plus constant of integration. This is your integration. So basic logic I have told you, but how to write it, let's see it. So this is how you are going to go about it. You have to write everything like we have, equating coefficients in like terms, putting and equation numbers. All this you have to write. Logic I have already explained to you. 2x divided by x cube minus 1. Now this x cube minus 1, we will just make it so easy. That is, if you just apply a cube minus b cube. A cube minus b cube is simply a minus b into a square plus b square plus ad. So a minus b, I am just expanding a cube minus b cube. A minus b, a square plus b square plus ab. Now you can take a as x, b as 1. It should be x minus 1 into x square plus x plus 1. Now this equation becomes like this. It will be 2x divided by x minus 1 into x square plus x plus 1. We'll take the partial fraction first. So a divided by x minus 1 will come because x minus 1 is a linear equation. For x square plus x plus 1, it will be bx plus c because it is a quadratic equation. Now just cross multiply. A multiplied by x square plus x plus 1. Now multiply bx plus c with x minus 1. In the denominator, x minus 1 into x square plus x plus 1 will be multiplied and kept. On the left it will be 2x divided by x minus 1 into x square plus x plus 1. You can cancel these two. Call it as equation number 1. Now 2x will be equal to ax square plus ax plus a. I am multiplying the interior terms. Bx multiplied by x minus 1. So bx square minus bx plus cx minus c. Now combine these similar term. That is a plus b into x square. Then ax minus bx plus cx. So a minus b plus c. Let me add a c along with x. Then we have a and c, a minus c. Only x term is there on the left, other terms will become 0. So a plus b will be equal to 0. A equals to negative b from here. And a minus b plus c will be equivalent to 2 on the left. A minus c on the left is 0, so a will be equal to c. So b becomes equal to negative a, c becomes equal to a. Now put it here. So what do we get? Because we replaced a by minus b, became plus. So 3a equals to 2, a becomes equal to 2 by 3. So c is 2 by 3, b will be negative 2 by 3, and a will also be 2 by 3. We'll put this value here. So we are going to just put these values. A is 2 by 3, will integrate like this. B and C will place negative 2 by 3 and 2 by 3 respectively. And since 2 by 3 is already coming, you can just take 2 by 3 outside. Please remember B is in negative. So minus x plus 1 will only come in the second term. I'll just show you how. So the integration has become like this. 2 by 3 integration of dx divided by x minus 1 plus 2 by 3 integration of negative x plus 1 divided by x square plus x plus 1. And if you remember, 2 by 3, negative 2 by 3 and 2 by 3 we have taken from the numerator of the second term and brought it in front of integration. First will become 2 by 3 log modulus of x minus 1. Now we'll integrate this. And you already know how to do this. We have done this in the previous exercises. But in short, I'm going to tell you. So minus x plus 1 will be represented like this. We'll have a constant a, differentiation of the denominator x square plus x plus 1, and then plus b. So negative x plus 1 here. Now a, differentiate this 2x plus 1 with a b. So minus x plus 1 will be equal to 2ax plus a plus b. So if you equate 2ax equals to negative x, x gets cancelled. A will be equal to negative half. So a plus b equals to 1. A has come as negative half. You can just cancel these two and write it as a equals to, it will be minus half, and b will be equal to what? It will get added to 1. It will be 3 by 2. So a and b is known to us. So 2 by 3 I1. I1 I'm calling this the separate term, which we just did. Now I am writing two separate terms of the second term, and I am multiplying already with 2 by 3. So a into 2x plus 1 into b plus b, I am writing for the negative x plus 1 and replacing a and b respectively by negative half and 3 by 2. This has come from negative x plus 1, and rest things remains the same. Now you have to multiply 2 by 3. So I am doing it separately. This separate and this also separate. 2 by 3 into negative half will be what? Negative 1 by 3. And 2x plus 1 remain in the numerator. And if you see, 2x plus 1 is the direct differentiation of x square plus x plus 1. And then 3 by 2 into 2 by 3. So this will get cancelled. Only integration dx divided by x square plus x plus 1 will come. Now these two will be done in a way which you already know. If you take x square plus x plus 1 as t, 2x plus 1 dx will be dt. It will be negative 1 by 3 log modulus of x square plus x plus 1. You already know that. Again, x square plus x plus 1, if you place it as t, differentiation of x square plus x plus 1, which is 2x plus 1, has already been computed just now. So it will be dt by t, and that will be simply log. How about this integration of dx divided by x square plus x plus 1? So the third term we are doing now. First two term we already got. So denominator we have x square plus x plus 1. The coefficient of x is 1. You can divide it by 2. Square it, add it, subtract it. So a square plus b square plus 2b is x plus half whole square. And 1 and 1 negative 1 by 4. That is going to be 3 by 4. So this will be root 3 by 2 whole square. That's a way of writing this in the order of 2. Root 3 by 2 whole square. Now we have a direct result. Dx divided by x square plus a square has a direct result. It is what? 1 by a and tan inverse x by a. X you will take as x plus half and a will be taken as root 3 by 2. So 1 by a tan inverse x by 1 by root 3 by 2 tan inverse x plus half divided by root 3 by 2. So this 1 by root 3 by 2 has become 2 by root 3. Tan inverse, this x plus half will become 2x plus 1 by 2. So 2x plus 1 by 2 in the numerator. Root 3 by 2 in the denominator. 2 gets cancelled. You have 2x plus 1 divided by root 3. Now this was your third term. If you remember, the first term was 2 by 3 log modulus of x minus 1. Second also I told you it's negative 1 by 3 log modulus of x square plus x plus 1. And the third term is 2 by root 3 tan inverse 2x plus 1 divided by 2x plus 1 divided by root 3 plus a constant of integration. It's your final answer. Now I divided various parts and showed it to you. Let's see a compiled version. So this is how you are going to write it. From here you are going to start. All the things which I told you is here only, but I told you each part how that will be done, but the composite part is in front of you. Alright, now dx divided by x square plus 1 and x square plus 4. So there will be a question coming like this, but normally what we'll do, let's take x square equals to t, or rather x square plus 1 is already there, so we'll put ax plus b in the numerator. In x square plus 4, we can take cx plus d and x square plus 4. Now, this is not the correct way. This is not the good way, but you can take x square equals to t. Don't differentiate it. You don't have to differentiate x square and t, because if you differentiate, there will be a separate x will come. So, it's better just change x square as t. So 1 by t plus 1 and t plus 4 will become a divided by t plus 1 and b divided by t plus 4. So now take the integration now. So this a and b can be computed, and you already know how to compute this. You don't have to differentiate, please remember. Just replace x square by just some t, because dt by dx will form 2x, and there will be a problem again because there is no x in the numerator. In the later stages, wherever it is applicable, replace x square by t. So the same question I told you. So x square now can be taken as t again here. So t divided by t plus 1, and here it will be 3t plus 4. Now you can write it as a divided by t plus 1 and b divided by 3t plus 4. Now just find a and b. You already know about that. We are in 42nd question. And just equate it. And a and b can be integrated easily because a and b are constants. Only you have to integrate the denominator, which is a partial fraction. And finally, x square will be replaced by t in the last way, means t wherever it is x square. Now 3x plus 1 divided by x cube minus x square minus x plus 1. Now this denominator seems to be worrisome, but you will see that we'll change the denominator in a way that will be very easily solvable. So x cube minus x square minus x plus 1, you can take x square common from here. X minus 1 will come. Minus x plus 1. Now take this x minus 1 common from these two. X square minus 1 will come. So you can write it as a square minus b square as a minus b into a plus b. So x minus 1 into x minus 1 into x plus 1. So 3x plus 5 divided by x minus 1 into x minus 1 into x plus 1. Now what we will do normally, we have three linear functions, so we'll write a by x minus 1, b by x minus 1 and c divided by x plus 1. Now this is wrong. This is not a good approach. You have to assume this x minus 1 as x minus 1 whole square. 3x plus 1 5 divided by x minus 1 whole square and x plus 1 will be written, and then finally it will be written as a divided by x minus 1. Then we have b divided by x minus 1 whole square. So this is how you have to write, and then c divided by x plus 1. This question can be easily disintegrated into partial fraction like this. So this you can do easily, I hope, and if you have any problem, just have a look here and revisit. Now in this question, the concept I explained you earlier, the order of the numerator and denominator are same. They have the same order, which is 3. In this case, we need to get the order of the numerator lower than the order of the denominator. So for that we need a division. We need to divide it. So this is how we divide. So we want x cube. For that we need to multiply it by 1. So it will be x cube, and this plus x will come here. Now we need to subtract. This subtract means x cube minus 1 minus x cube plus x. So this gets cancelled. I'll show you here. X cube minus 1 minus x cube minus x. X cube gets cancelled. You will get negative 1 and minus x. So it's basically negative 1 plus x. So how do we write this? The same integral which I am talking about, it can be written in this form. So let's go along with this negative 1 plus x. I am taking negative outside, 1 plus x remain like this. So we have x cube plus x in the denominator. Now this can be done easily. If you call it as I, we have to integrate this first, and this is the second part. So the first integration is x. Please remember, because I am going to add it later. And this I1 I am going to do, or we are going to do just now. For that, this 1 plus x divided by x cube plus x. This x cube plus x in this, the denominator, you can take x common, you will get x square plus 1. So x into x square plus 1 you will get. Now when we have the order 1 in the denominator, we take a, constant a. X square plus 1 is bx plus c, and this is Denominator will be x square plus 1. Now let's cross multiply. A multiplied by x square plus 1, and here x multiplied by bx plus c. In the denominator, it will be x into x square plus 1. Here you have 1 plus x divided by x into x square plus 1. You can cancel these two in the denominator. So let's multiply. 1 plus x equals to ax square plus a plus bx square plus cx. Now take the similar term and combine them. A plus b x square, then we have cx, and then we have capital A. Now we'll equate the similar terms, that is the coefficient we are going to equate in order to get the constant values, which we have used as a, b, c. Now on the left there is no x square, alright, so 1 plus x is there but x square term is not there, so a plus b equals to 0, c will be equal to, we have an x term there, so c became 1 and a is 1. Now a is 1, therefore b will be equal to negative 1 because b is equal to negative a. B become equal to negative 1, a is equal to 1 and c is equal to 1. We'll put it here. Now when we put it here, and then we can integrate it easily. So I'm going to write this just now. So we are talking about I1. The integration of dxx is already done. This I1 is the second part. So integration of 1 by x, because we have transformed this integration, the second part, into this one. 1 divided by x plus 1 minus x by x square plus 1. You can just divide this and separate these two terms, 1 by x square plus 1 and negative x by x square plus 1. We are going to integrate them separately, and we have done it quite a number of times, so you are well aware of that. 1 by x is directly log modulus of x. This can be 1 by 1 plus x square. You can write it as 1 by 1 square plus x square, that means integration of 1 by a square plus x square. And all this will be changed into negative because initially x was there, then minus integration of I1. That means all these terms are going to be changing sign. But for now, 1 by a square plus x square is tan inverse x by a. In this case, x is x and a is 1. So we have tan inverse x. How about this one? See, this we have done, I think, 100 number of times. So half log modulus of x square plus 1. This is a direct result. I hope that you are quite well versed with it. So x minus this whole term which we just got. So now I'm going to change all the signs here and combine it with x in order to get the final result. So x minus log modulus of x plus half, I'm taking it in front, half log modulus of x square plus 1 and minus tan inverse x. When one is missing, you can just add it. Now how this is going to be written, that's very important. You have to start from here, you have to divide, and then followed by all the instructions which I provided you, you can get this result. All the English things you can write. X square plus x plus 1 divided by x plus 1 whole square x plus 2. Now this is quite clear to you because we are on the 45th question. This kind of question we have already done, so I'll just tell you how to make this as a fraction or partial fraction. A divided by x plus 1, b divided by x plus 1 whole square, and then we have this x plus 2, so you can just have a c here. Now just integrate this, you already know because there are two terms with just linear equations. One with x plus 1 whole square, you already know negative 1 by x plus 1 will come for that integration. So this is how this can be done. It's very straightforward. I hope you'll be able to do it. This is the reference you can follow. 1 by x multiplied by x raised 4 plus 1. Now there are a few questions which are going to be in front of you, and those questions will follow this scheme, so you need to understand this question very carefully. X raised 4, you always tend to notice the highest power, and you should, because we need to do something across or around this x raised 4. If you differentiate this x raised 4, 4x cube will come. That's why x cube and x cube I have multiplied in the numerator and denominator. Now what is the advantage? When we take t equals to x raised 4, or you can take t as 1 plus x raised 4, whichever way you like, because in both the cases the result is going to be the same. So it's better that if you take t equals to x raised 4, you can just avoid this, but you can take that also, it's up to you. When you differentiate dt by dx, 4x cube will come. So dt by 4 has become x cube dx, and since we have multiplied x cube in the numerator as well as the denominator, x cube dx can be directly represented by dt by 4. And in the denominator you have x raised 4 because x cube into x is x raised 4, and 1 plus x raised 4 is 1 plus t, and as I just indicated, x raised 4 can be written as t minus 1, or you can write it as This x raised 4 plus 1, t plus 1 also you can write. Both the ways the same result is going to come. So the main idea is to find the partial fraction of 1 by t, t plus 1. So a by t plus b divided by t plus 1. So just cross multiply a multiplied by t plus 1 plus b multiplied by t divided by t into t plus 1. Here 1 by t, t plus 1. So just cancel this out. At plus a plus bt, this becomes equals to 1. So you can take this t common, a plus b will come, and then a will come. So 1 on the left. So from here directly a becomes equal to 1 and a plus b will become equal to 0. When you put a equals to 1, b will be equal to negative 1. So you'll get 1 by t minus 1 by t plus 1. Now I'm integrating. We can do it in one screen only, so don't worry. Log modulus of t minus log modulus of t plus 1 will come. And you already know that log a minus log b. Let me write it. Log a minus log b is log a divided by b. Log a plus log b is log a into b. Log a minus log b is log a divided by b. So this will become log t divided by t plus 1. 1 by 4 is already there. But if you remember, what was t previously taken? So I'm writing the final answer right now. I becomes equals to 1 by 4. Here you have log t x raised 4, x to the power 4. So this will be x raised 4 divided by 1 plus x raised 4 plus constant of integration. This whole is your final answer. Now this is how you're going to write it, because once you know the logic, all these English things we have, putting, all this can be added. Logic is important. Why we multiply numerator denominator by x cube? If you understand that, then I hope and I wish that this question and questions which are related to this question will be very clear to you. 1 by x cube plus 8. Now again, you will be tempted to multiply this numerator denominator by some number. See, 1 by x was there, we just formed a by x. 1 by x plus 1 whole square. What did we form out of this? I'm just saying how to form the partial fractions. For that we wrote a divided by x plus 1 followed by b divided by x plus 1 whole square. This already has been indicated to you. When you have a quadratic equation in the denominator, say ax square plus bx plus c form, then you will write bx plus c divided by that particular quadratic equation. In this case, I'm giving you an example of x square plus 1. Now this is just for example. But here we have x cube. When you have x square plus 1, you have, see, linear equation in the denominator, constant in the numerator. Quadratic equation in the denominator, bx plus c form. But when we have a equation with 3 power, that is a polynomial here, because order has increased, it has become 3 now. So this x cube plus 8 will be written like this. It will be a divided by x. This is quite clear to you because this is a linear equation. X is a linear equation. In x cube, what will be the power above? It will has to be square. 1 power lower than what is in the denominator. So you don't have to write bx plus c, you have to write bx square plus cx plus d. You have to have a quadratic equation over this x cube plus 8. This is very important. This is the whole core of this problem. Alright, now already you know how to go about it. Multiply, cross multiply, take the LCM of these two terms. A into x cube plus 8 plus x into bx square plus cx plus d. In the denominator you can have x into x cube plus 8. There is x also, I have not written, just assume that x is there. Now you can just cancel these two out in the denominator. So multiply the numerator first, ax cube plus 8a plus bx cube plus cx square plus dx. So I'm combining these terms. I'm not writing x into x cube plus 8 in the denominator just now. I'm just showing you that I'm combining these two terms in order to get these similar terms which can be equated to the left side. And on the left, it is just 1 on the left. Then we have cx square, then dx, and then 8a. So on the left, if you check, only 1 will be there because x cube plus 8 into x definitely is going to be cancelled. Now a plus b becomes 0, c becomes 0, d becomes 0. Only 8a will be equal to 1. Why? Because there is only constant term on the left hand side which is actually 1. So a became 1 by 8, b became negative 1 by 8 because a plus b equal to 0, c is 0, d equal to 0. So in place of a we are going to write 1 by 8. These became 0, only b has come which is negative 1 by 8. So let me put negative here 1 by 8. I'm not doing it right now, I'm just showing you where I'm going to replace all these in the actual integration which is following just now. So the integration will become something like this. 1 by 8 integration of dx divided by x negative 1 by 8 for b, and then integration of x cube plus 8 in the denominator and dx in the numerator. The first term you are quite clear about it. 1 by 8 log modulus of x. Now you'll ask the question dx divided by x cube plus 8. How we are going to do that? Now x cube plus 8, we have to concentrate on x cube. See, 8 can also be written as 2 cube, but d by dx of x cube is what? It's 3x square. So if you take x cube as t, dt by dx will be equal to 3x square. So you need a 3x square actually. 3x square dx will be dt. So if you want a 3 here, 3x square, this is dt. If you assume x cube to be t, this will come. You can write this dt. If you remember, bx square negative 1 by 8, x square was already there. I didn't write it. It was already there. I just missed it to show you actually. That was in my mind, but I didn't show you. Remember, x cube was already there with negative 1 by 8. So this 3x square dx can be written as dt by t. X cube plus 8 was taken as t. Log modulus t will come. Log x cube will come. And one more thing you can do. You can take x cube plus 8 as t. See, in order to make this, I'm just showing you. There are multiple ways which are possible. X cube, you can take t. But if you take x cube plus 8, then this 8 will be eliminated. You don't have to do anything with that. Otherwise, x cube equals to t, so you have to deal with 1 by t plus 8. That will be a problem. So x cube plus 8 has to be taken as t. 3x square will come automatically in the numerator. With the dx it will become dt, and then log x cube plus 8 will come. So let me write it very clearly, because there are certain things which I explained you. 1 by 8 log modulus of x minus 1 by 24. Log modulus of x cube plus 8 plus constant of integration. This is your final result. And this is how it has to be done. It's a quite simple question, but this is a new kind of question. X cube plus 8, how to deal with this? This is quite clear to you. This question is very easy. A divided by 1 minus x you will do. And then bx plus c divided by 1 plus x square you will do. Because 1 plus x square is actually indeed a quadratic equation. 1 minus x is a linear equation. That's why we had a on it. So there is nothing special in this question, and you can do it. Now in this question, it seems to be having some trigonometric content here, but it will be done like that. There is a new thing, a new concept which is to be explored here. So be aware that this is a different kind of question, not matching to what we have done earlier. So we need this cos x dx in the numerator. For that, what we do? We already have a sin x in the denominator. So we'll take t equals to sin x, dt by dx will come as cos x. That means the cos x dx will be equal to dt. This is the first thing. So this integration after taking t equals to sin x will be like this, dt 1 minus sin x whole cube, that is 1 minus t whole cube, and this will be 2 plus t. Now the important thing here is 1 minus t is not just 1 minus t, or it is not 1 minus t square, it is 1 minus t whole cube. For that we have to do some different approach for the partial fraction. So let me write this 1 by 1 minus t whole cube, 2 plus t. And this equals to what? There are 3 powers. Till 2 powers or 1 minus t whole square, a quadratic version, we have already done. But here it's polynomial with the power 3. So it will be a, b, c. For 1 power, 2 power, 3 power. So 1 minus t will be below a, 1 minus t whole square will be below b, and 1 minus t whole cube will be here. Now this is done. So this is what you have to understand in this question. And d divided by 2 plus t is already there. Now let's take the LCM. Now there will be a lot of multiplication you have to do. You have to know the 1 minus t whole cube also. And I hope that from standard 7 to standard 11, you have already done this a, b, c, d, finding the linear equation, the quadratic equation, etc. So the denominator will be 1 minus t whole cube in this case, along with a 2 plus t. So you already have a 1 minus t, so you'll have 1 minus t whole square along with 2 plus t with a. I'm just showing you what will come with a, b, c, d, but I will strongly encourage you to find out this a, b, c, d yourself. I'll tell you the values and take you to that extent where a, b, c, d can be found out. With b, 1 minus t, 2 plus t. With c, it will be 2 plus t. And with d, it will be 1 minus t whole cube. Now what you can do is 1 minus t whole cube can be written as t minus 1 whole cube with a negative sign. That I'll just show you in a while. But let's complete this. On the left it will be 1 minus t whole cube and 2 plus t already is there. Now you can just cancel these two out, and I hope you'll be able to find out a, b, c, d from this. It's pure algebra which you have already done in the previous classes. There is also one possibility that what t you can put 1, t equals to -2, but might be possible you won't achieve other constants. So it's better just to open it up, equate it with the left side coefficients, and then find out the values of a, b, c and d. So this a, when you'll compute it, a will come as 1 by 27, b will be -1 by 9, c will come as 1 by 3, and d will be -1 by 27. All these values are going here. A will be replaced by 1 by 27, B will be replaced by -1 by 9, C will be 1 by 3, and D will be -1 by 27. And then we'll just take these constants outside and we'll integrate them. Integration is quite easy. That already is done by you multiple times in this exercise. Now there one more thing which you can do here. If you want, you can do. If you don't want, it's up to you. It's not a necessity. This question does not demand it, but you can do it just to match the answers in the R.D. Sharma solutions. So 1 minus t, you can write t minus 1. For that you need to have a negative outside. 1 minus t whole square, t minus 1 whole square remains the same. But 1 minus t whole cube, if it is written as t minus 1 whole cube, then you ought to have a negative in front. So the negative for two of the terms can come out, and then now you can replace this 1 minus sin x by sin x minus 1 everywhere. If you want, let me re-emphasize, if you want you can do it, but if you don't do it, there will be no deduction in the marks. The question doesn't demand it, only the answer in order to match with the R.D. Sharma solutions, we are doing it. Alright, so 1 by 27 dt divided by t minus 1 now, and I will multiply them later with negative. So 1 by 9 integration of dt, this is negative 1 by 9 dt divided by t minus 1 whole square. Then the third one will be 1 by 3 t minus 1 whole cube, and this will be -1 by 27. So I've already done t minus 1 and t minus 1 whole cube. The last term will be this one, -1 by 27 multiplied by dt by t plus 2. So 1 by 27 log of modulus of t minus 1. Please remember, t was taken earlier as sin x. So that will be replaced in the latter part. 1 by 27 dt by t plus 2 will be log t plus 2. Now this will be dt by t minus 1 whole square will be -1 by t minus 1. So this becomes plus 1 by 9 1 by t minus 1, and this one will be, again you can just take this t minus 1 whole cube upstairs. It will be t minus 1 to the power -3. When you integrate it, it will be x to the power n plus 1 by n plus 1 kind of thing. So this will be -1 by 2 into 3 becomes 6 t minus 1 whole square. Now just change the sign, as I told you that this negative has come out because of this t minus 1 and t minus 1 whole cube conversion. So one only thing is remaining, which is the replacement of sin x in place of t. So I'm writing the final answer, -1 by 27 log, it will be sin x minus 1. This will be plus. So you don't confuse yourself with the signature. Sign, the only thing you have to concentrate is that how to do this 1 minus sin x whole cube partial fractions. If you understood that, these signs will not matter. Sometimes it will be negative, sometimes it will be positive. It doesn't matter. The whole idea is to get this 1 minus sin x whole cube as a, b and c divided by a divided by 1 minus sin x, b divided by 1 minus sin x whole square, and c divided by 1 minus sin x whole cube. So this I is finally this one. So if you want to check if you're doing it by yourself, then you need to follow, or you can follow these steps. It's been clearly being shown. And if you want to write 1 minus t, you are good. If you want to write t minus 1, you are most welcome. Next one is 2x square plus 1. In the denominator, if you see, numerator has the power 2, but denominator has the power 4. So you don't need to divide it because the numerator power is way less than the denominator. So 2x square plus 1, for x square we can have a divided by x square. Oh, this is a quadratic equation. Then what to do? So there is a way. So right now the approach we followed, or I told you, is not correct. X square you can put as t, but the question next will be, oh, I have to differentiate it. No, you don't have to differentiate it. See, x square can be anything. It's told to you. I can think of it as a p or a t, right? So I don't have to differentiate it all the time. So just write this t in place of x square. It is just a name, like, you know, you have some name and your house name is different. That's how it's being. Because it will become easy. This can be written as a by t plus b by t plus 4. Because x square we have replaced by t without differentiation. So this will be in partial fractions. A and b will come, and then you can integrate it easily. But before integration, you have to convert this t again to x square, because x square is just a replacement. It's not differentiation. So this a into t plus 4a plus bt equals to 2t plus 1 on the left. Combine the terms, so a plus b into t, and then we have 4a. Now equate it. A plus b will come as 2 and 4a will come as 1. So a becomes 1 by 4. You can put it here, 1 by 4 plus b equals to 2. So b will be 2 minus 1 by 4. That is 8 minus 1 by 4. 7 by 4 will come. Now put it here in this one. And you need to integrate as well. A divided by t is 1 by 4. And then integration of what? You are not going to write dt or etc. Alright? Because x square equals to t is just a different way you are calling a person. Different name. You're not replacing it actually. You're just trying to know x square as t. So dx divided by x square will be there. Because I told you before integration you have to replace t by x square. And next one is 7 by 4. Dx divided by x square plus 4. Now x square you already know, dx by x square is negative 1 by x, so negative 1 by 4x will come. How about this 7 by 4 along with dx by x square plus 4? This x square plus 4 can be written as, because it is a square plus b square type. So x square plus a square type. So 1 by a tan inverse x by a will come, because integration of dx divided by x square plus, in this case you can write 4 as 2 square. So this will be 1 by 2 tan inverse x by 2. 7 by 4 is already there. So 7 by 4 into 1 by 2, 7 by 8 tan inverse x by 2. Plus constant of integration. This is your final answer. Alright. This is the concept here. It's a different kind of question. That's why it was necessary to tell you that questions can be done in this way also. You don't need to differentiate it always. Let me tell you again. I'm reiterating. For example, you have some name like Kavindra, V, some Sayadri, Manindram, but let's call you Mr. Champu. That's the same thing. That's why x square can be written as t. Now this question, only trigonometry is seen here, but once you eliminate the trigonometric content, you will see it will be the most easiest question until now. If you replace t by sin x, dt by dx will be cos x. So this dt will become cos x dx. This is not cos 2, this is cos x. So this integration will become this dt is cos dx. Cos dx is already in the numerator. So this will form dt in the numerator. In the denominator, it will be 1 minus t and 2 minus t. And this dt by 1 minus t and 2 minus t can be written in the form of partial fraction. So this will be like this. You have a divided by 1 minus t, then you have b divided by 2 minus t. Now one more thing, you can have this 1 minus t and 2 minus t change their positions with a negative sign. That means you can have t minus 1, you have to take negative out. I'll show you here because it has to be done earlier. T minus 1 if you take negative, it can be taken out. T minus 2 if you do negative can be taken out. Negative becomes positive. So this will be 1 by t minus 1 and t minus 2. So a divided by t minus 1 plus b divided by t minus 2. Now here we have a and b. So this is integration of, because a and b, if I hope you'll be able to compute. A will come as this value and b will be 1. Okay. So a and b, I hope you'll be able to compute it. You just have to integrate these two. Integrate. This will be log t minus 1 and then log t minus 2 and finally replace it by sin x. That's why the basic thing I've told you about this question, from here to here you can do it by yourself. There are certain things which needs to be explained, like negative was taken out. So this is quite a self-explanatory solution. This is also a very easy question. It's also straightforward. So you can just refer to this solution if you are doing it by yourself. And there will be some -5 and 7 will come. You can just take it inside to the power log a minus log b formula. You can use log a by b. Now this is more easier than the previous one. Now you have understood that x square equals to t you can put, or some p you can put, and you don't have to differentiate it all the time, which we have learned earlier. So 1 by t plus 1 and then t plus 2 can be written. This will be a divided by t plus 1 plus b by t plus 2. Just find a and b, integrate this t, and before integrating you have to replace it by x square, because you haven't done any differentiation with x square. Alright, we haven't differentiated it, remember, just given an alias or different name to x square, which is t here. Now 1 by x raised 4 minus 1. So this also has been done. It was just x raised 4 plus 1 previous time, and you just have to multiply numerator denominator by x cube, and the reason was being told to you earlier also. Okay, this question is somewhat different for those who have higher IQ. They know how to do it, but others who would like to understand this question, for the completion's sake, let me tell you that x raised 4 minus 1 can be written as x raised 4 minus 1 raised 4. So you can write it as x square to the power square and 1 square to the power square. And a square minus b square is a minus b into a plus b. A you will take it as x square, b you will take it as 1 square. So x square minus 1 and x square plus 1 come. Now this x square minus 1, that is x square minus 1 square, we can be written as a minus b, a plus b. So x minus 1 into x plus 1. Then you have x square plus 1 here. Now I hope you'll be able to do this, because in the denominator you have 1 by x minus 1, x plus 1 and x square plus 1. And this kind of question was exactly being done, but it was not matching this, You never knew that 1 by x raised 4 minus 1 can be just written as 1 by x minus 1 into x plus 1 into x square plus 1, which can in turn be written as a divided by x minus 1 plus b divided by x plus 1 plus b cx plus d, because it's a quadratic equation, x square plus 1. So x square plus 1. And with this knowledge you can find out a, b, c, d, and you can integrate. First and second is quite easy. Third one, maybe you have to use this x square plus a square formula. So reference has to be shown to you because we are on the 55th question. So I hope that the previous questions which we have already deliberated and done is now in your mind. And x minus 1, x plus 1 and x square plus 1, if you can change x raised 4 minus 1 to this, the integration becomes quite easy. Now in this question, this is a quadratic equation. Again, we have a quadratic equation with a square, and we have a x. So from x square we can get x. So I'll take you to that level where you can take over or you can solve it. So first thing is, you have already seen x. That is the output of the differentiation of x square. So let's take t equals to x square. This dt by dx will be equal to 2x. Now this 2x dx is already there in the numerator. So this dt will become 2x dx. So this I will be like this. So we have dt divided by x square will be t plus 1, and this will be t plus 2 whole square. It's 2. So what is the benefit? Now this is the form you are already aware. You can write the partial fraction in this form, a divided by t plus 1. Then we have t plus 2 whole square. For that we can have b, and this is t plus 2, and then c divided by t plus 2 whole square. So there are three things here, and I hope you'll be able to solve a, b, c, and after that put x square equals to t. It means replace t by x square finally. So this is the reference. If you are stuck anywhere, you can take the reference here. As we have done question like this, that's why I'm just giving you a reference so that you can do it by yourself. Now again, this question, in the denominator it is x cube, numerator x square, so you can have a direct partial fraction without even dividing. You can have a divided by x minus 1, and then we have bx plus c, because x square plus 1 is a quadratic equation. For that you need bx plus c. Now this has to be equal to what? X square by x minus 1 multiplied by x square plus 1. So again, this question is very self-explanatory. It's very straightforward. Now this one, okay. Now you will be tempted to take this x square as t and try to differentiate it. And with our previous discussions, I always tell you that all the time you don't have to put this x square as t and you have to differentiate it. Sometimes you just have to perceive this x square as some other element or symbol. So just assume this x square equals to t or p or any letter different from what we have seen here. But you don't have to differentiate it. Why? Because if you write x square equals to t, this integration or this expression will become t by t plus a square and t plus b square. And don't worry about a square and b square, these are just constant. Assume it to be t plus a and t plus b like that. So since this is just a linear equation, it will be a divided by t plus a square and b divided by t plus b square. Even if it is a raised power 100, doesn't matter, it's just a constant. So now cross multiply a into t plus b square plus b into t plus a square. In the denominator it will be on the left t plus a square and t plus b square, so the same denominator will come on the right hand side as well. So t plus a square into t plus b square. Now just cancel these two denominators and multiply the inside. So at plus ab square plus bt plus ba square, and you can take t common and equate it with the similar terms on the left. So you'll get a plus b into t and ab square plus ba square. Again, I was saying that denominator can be cancelled. So you can just write one more step and cancel them out. This will be t divided by t plus a square again, t plus b square. Cancel these two terms. T will be equal to, now multiply this inside, a plus b into t will be what? You don't have to multiply, actually you just equate. So if you see on the left, it will be only t as a term. So a plus b equals to 1 and there is no constant term here. So ab square plus ba square will be equal to 0. A you can write it as negative ba square divided by a square divided by b square. Now you can write this b as first, b plus a is negative b, a square by b square, this equals 1. Now if you take b outside, 1 minus a square by b square, this equals 1. That means b into small b square minus a square divided by b square becomes equals to 1, and that will give you b as b square divided by b square minus a square, and a is what? 1 minus b. So 1 minus b square divided by b square minus a square will come. So b square minus a square b square minus a square minus b square divided by b square minus a square, this becomes a. You can cancel this out. Now the a has come as negative a square divided by b square minus a square. Now this a and b will put it here in these places and then we'll integrate it. So when I'll integrate, I will keep this a and b in front of the integration sign. So what I'm trying to suggest here is a already computed, b already computed. With this negative a square divided by b square minus a square, inside integration it will be 1 divided by, or dx divided by, please remember t was taken as x square, so you need to replace it. Means you cannot have t inside an integration. It was just an alias or a different name from x for x square we have taken. So this is dx divided by x square plus a square and b squared by a square, b square minus a square, that is a constant again outside. So 1 divided by x square plus b square dx. And don't worry about the constants now. Dx by x square plus a square or x square plus b square, they will follow the same scenario, which is 1 by a tan inverse x by a. 1 by x square plus b square integration will be 1 by b tan inverse x by b. So minus a square divided by b square minus a square, and 1 by a tan inverse x by a. Now b square divided by b square minus a square. Now if I replace this by b, it will be 1 by b tan inverse x by b. So you can have it here, 1 by b tan inverse x by b plus a constant of integration. That's your final result. If you want to make it more easier, well, you have already achieved the answer which was expected out of you. But you can just have some simplification. You can take 1 by b square minus a square outside. That is, I'm just exchanging these two terms because negative is the first time. I want to keep it in the middle. So 1 by b square minus a square you can take outside, and the second term I'm writing first. B and b square, 1b gets cancelled, so it will be b tan inverse x by b, and this will be negative. A gets cancelled, so a tan inverse x by a plus a constant of integration. So this is the way you are going to do it. Actually, we have done a question like this earlier, but we cannot skip every question, otherwise candidates or audience will get angry. Now 1 by cos x 5 minus 4 sin x. So when you have the denominator all sine, when you have a denominator all cos, and you have a complementary value, that is, say denominator you have all sine, numerator you have cos. You can do that easily. Or denominator all cos, numerator sine. You will just put one value and the differentiation will be the above value. But here cos x and sin x, they are different values. You find it in the denominator. So in order to solve this, there is a different approach we are going to take. We know that sin square plus cos square equals to 1. So this is 1 divided by cos x, and this is 5 minus 4 sin x. Now multiply numerator and denominator by cos x. So this is cos x dx, and the denominator you have cos x into cos x, that becomes cos square x, and cos square x is simply 1 minus sin square x. You already know that. So this is 1 minus sin square x, because sin square x plus cos square x equals to 1. And then we have 5 minus 4 sin x. 1 square minus sin square x is what? A square minus b square, a minus b into a plus b. So 1 minus sin x into 1 plus sin x you can write. So this will be cos x dx divided by 1 minus sin x into 1 plus sin x, and then we have 5 minus 4 sin x. So now the integration will be done, and I am quite sure that when you take sin x equals to t, you will get a cos x dx in the numerator, and the formation will be so easy that we have already covered it later. Like I'll just show you. T equals to sin x dt by dx will be what? It will be cos x. So dt becomes equals to cos x dx. So this cos x dx will be dt, and denominator will be what? 1 minus sin x, which is 1 minus t, 1 plus sin x is 1 plus t, and 5 minus 4 sin x is 5 minus 4t. Now you have reached up till this extent. You can write it as a divided by 1 minus t, because I just expect that you need to solve this a, b, c. So 1 divided by 1 minus t, b divided by 1 plus t, and c divided by 5 minus 4t. So you have to solve it for a, b, c, and a will come as 1 by 2. You can just integrate dt divided by 1 minus t, which is log 1 minus t, with a negative sign also. I'll just tell you why. This will be, b will be 1 by 18, so this will be log 1 plus t, and this will be, c will come as, so c will be negative 16 by 9, and this dt by 5 minus 4t, when you take the differentiation of 5 minus 4t, because once you take the integration you have to differentiate 5 minus 4t, negative 4 will come, and that will come in the denominator. So when this negative 1 by 4 will come, for the 16 it will be 4 by 9, negative 4 by 9 will come along with this. So this was already been explained, because the basic thing I have already explained. And when you will take this 1 minus t, log 1 minus t, you have to differentiate 1 minus t, negative 1 will come, that has to go in the denominator. Similarly, this 1 plus t, log 1 plus t will come upstairs, and 1 plus t differentiation is 1, so 1 will come in the denominator, that won't affect. And this 5 minus 4t will give you negative 4, that has to come in the denominator. As I said, this 4 will get cancelled, negative will get cancelled, it will be plus 4 by 9 log 5 minus 4 sin x. So this is the reference you can use if you are solving it by yourself. And the same theory, same discussion will be here. Only the sin x and cos x has changed. Previously it was cos x in front, now here's sin x in front. The technique will remain the same, because when you take cos x equals to t, it will be differentiation will be minus sin x. So sin x will come up upstairs. So you need to have this sin x upstairs. For that you need to multiply this sin x numerator denominator. So sin x is in the numerator, sin x in the denominator, sin into sin x will be sin square x, and 3 plus 2 cos x. So this sin square x will be 1 minus cos square x, you already know that. So sin square x plus cos square x equals to 1. 1 minus cos square x is 1 square minus cos square x, which is a minus b, a plus b. So 1 minus cos x into 1 plus cos x will come. So this whole will come as sin x divided by 1 minus cos x into 1 plus cos x, and in the denominator it will be 3 plus 2 cos x. So if you want to integrate it, you have to take cos x equals to t. So dt by dx will be equal to negative sin x. So negative dt will be equal to sin x dx. So minus dt will be equal to sin x dx. Sin x dx you can write it as negative dt. But what you see here, 1 minus cos x is there. 1 minus t you can write. 1 plus t as 1 plus cos t. And then 3 plus 2 cos x, which is 3 plus 2t. Now you can just replace this or remove this negative in front by just taking t minus 1 in place of 1 minus t. Because when you take t minus 1, negative will come out. Negative was already outside, that will get cancelled. And when you take the partial fraction, it will be a divided by t minus 1, b divided by t plus 1, and then c divided by 3 plus 2t. ABC you can compute easily. So I'll tell you what the ABC is going to come. A will be 1 by 10, and b will come as negative 1 by 2, and c will be equal to 4 by 5. And when you integrate this will be log t minus 1. So 1 by 10 log t minus 1 will come. But you have to replace this t by cos. So 1 by 10 log cos x minus 1 will come as the first term, minus 1 by 2, log t plus 1 will come. So you can take log modulus of cos x plus 1. Then we have 4 by 5. So this will be log 3 plus 2t. But when you differentiate this 3 plus 2t after integration, 2 will come and that will go in the denominator. So 4 by 5 multiplied by 1 by 2, that will give you 2 by 5. So plus 2 by 5 log 3 plus 2t will be your final answer along with a constant of integration c. So I just told you very briefly and you'll be able to do it. And if you have any problem, this is the reference. You can follow this. The procedure and the concept I already explained you. Rest things are quite easy. So until this point, it was my duty, but other things you can just practice and find it out. 1 divided by sin x plus sin 2x. So before the integration, let me just try to resolve this first. 1 by sin x is there and then sin 2x can be written as 2 sin x cos x. This sin x can be taken outside. 1 plus 2 cos x will come. And the same thing, see, is this question equivalent to the previous two questions we have done? Yes. These are exactly similar to the previous question. Multiply sin x in the numerator denominator. You'll get sin x in the numerator. Sin square x will be 1 minus cos square x you can write. And 1 minus cos square x can be written as 1 minus cos x, 1 plus cos x. 1 plus 2 cos x is already there. So this sin square x is an important concept. How did we come up until here? This sin x is already upstairs with the dx. Denominator we have all cos x. So 1 minus cos x, 1 plus cos x, and then followed by 1 plus 2 cos x. And you ought to take this cos x equals to t. So when you take t equals to cos x, dt by dx will be what? It will be negative sin x. So d minus dt equals to sin x dx. So this numerator is negative dt. Now again, this negative can be replaced or it can be removed by taking 1 minus cos x as cos x minus 1. So when we take this cos x minus 1, this negative dt will become dt only. So it's better to write cos x minus 1 rather than 1 minus cos x. So this will be t minus 1 now, t plus 1 now, 1 plus cos x can be written as t plus 1 and 1 plus 2 cos x will be 1 plus 2t. Now you can just forget about the integration sign. First find out the partial fractions, the constant. So a divided by t minus 1, b divided by t plus 1 and c divided by 1 plus 2t. So 1 by 6 a will come, 1 by 2 will come in front of this and c will come as negative 4 by 3. So when you integrate this, see when you integrate this one, all constant I told you that you will be able to compute. It will be log t minus 1. So log cos x minus 1 will come. So let me write it just to show you. 1 by 6 log cos x minus 1 will be the first term. After computing b, half will come. And you can write this log cos x plus 1, 1 plus t or t plus 1. And this is 1 plus 2 cos t, 1 plus 2t. So this 2 will remain. That is log 1 plus 2 cos t will come. 2 cos x will come, but 1 plus 2t, when you will integrate this this differentiation will also be done. 1 plus 2t differentiation will be 2 and that will go in the denominator. So 1 by 2 multiplied by 4 by 3. So you can write just 2 by 3. So this whole is actually what I have written is the answer. Whole process you have to follow. I just gave you a hint because this question is quite easy as we have done these previous 59 and 60th question, which is equivalent to this question. In the previous question, what we have seen, that we need something in the denominator so that we can have a differentiation in the numerator. So if we place t equals to x into e raised x as t, then dt by dx, that is the differentiation, will give me x e raised x plus e raised x. I have used the product rule. When we take e raised x or e to the power x common, 1 plus x dx will come because dx can be multiplied on the right. So this e raised x 1 plus x dx has come. But in the numerator, this x plus 1 into dx is in the numerator. For that we need e raised x also. So numerator denominator can be multiplied by e raised x. So this integration will become something like this. This e raised x 1 plus x dx, this can be written as dt, and this e raised x into x has already been taken as t, so you can just write t in place of that, and then 1 plus x into e raised x can be taken as 1 plus t. Now this question, which seems to be highly complicated, has taken a shape of a simplified version. So 1 by t plus 1 will be equal to a divided by t plus b divided by t plus 1. This will be a into t plus 1 plus b multiplied by t divided by t into t plus 1. On the left it will be 1 by t plus 1. The denominator will get cancelled and we'll multiply this at plus bt and this a. On the left, it's 1 only. So when you take t common, a plus b will remain, and a, because the only constant on the left is 1, a become 1 and a plus b will be equal to 0. That will give you b equals to negative 1. If you put a equals to 1, it will come as negative 1. Now put it here in place of a1, in place of b negative 1. And when we integrate this I will be equal to integration of, and this dt divided by t, and since b is negative 1, so I'm taking negative outside, integration of dt divided by 1 plus t or t plus 1. Now this will give you log modulus of t, and this will give you log modulus of 1 plus t or t plus 1. This will become log t divided by t plus 1 plus a constant of integration. Now please remember, t was initially taken as x into e raise x. You can write it like this: log x into e raise x divided by 1 plus x into e raise x inside the modulus along with the log plus constant of integration. This is your final result. Now how to do this? The only thing is x into e raise x to put as t and differentiate is the whole idea of this question. Now next question, there are so many x squares here. First we'll take them as alias, that is x square as some t or p, but still we have the similar power in the numerator and denominator. For that we need certain division. Let's see how it shapes. When we take x square equals to t, we are not differentiating it, we are just taking an alias, a different name from x square, and that x square is called as t here. And replacing x square by t, this expression becomes like this. But since the numerator denominator has the equal power, even if you multiply t square and t square will be numerator and denominator. So let's multiply this, because we need to have a quadratic equation, because these are just factors. And this factor might have come out of the previous classes. You are aware that t plus 3 into t plus 4 is t square plus 7t plus 12. Now since the order are same, when we want to integrate, and in order to find out the partial fraction and to simplify this, we ought to have a division. So t square plus 7t plus 12 here, this is t square plus 3t plus 2. Now you need a t square, and t square is already there, so you have to multiply it by 1 only, and this whole expression will come below this, and now subtract these two equations. T square gets cancelled. 3t minus 7t is negative 4t. 2 minus 12 is a negative 10. So this will be written in the clockwise direction, like first one, and since 4t plus 10 along with the negative is equivalent to negative 14 minus 10, so we have taken a negative outside. 40 plus 10 will remain like this, and the denominator will be t square plus 7t plus 12. This is how it will be taken. So this is I, and when we integrate these, what do we get? See, 1 is only, and this t is not the dt. What I'm saying is x square was not differentiated, so you cannot have dt. It's just something integrated. There is nothing, only 1 is there, so it will be x only. So there is a slight mistake which I have committed here. Assume it to be only x, not x square. Now the second part we are calling it as I1, which is 4t plus 10 divided by t square plus 7t plus 12. So we are now moving forward for this I1, which I presumed, and we call it as 4t plus 10 divided by t plus 3 and t plus 4. We are not changing it to x square right now as t. We are trying to find out the partial fraction. So a divided by t plus 3 plus b divided by t plus 4 are the two factors which we can form. For that we need a and b as certain constant value, which we will find out just now. So take the LCM. T plus 3 and t plus 4 will come in the denominator. So at plus 4a and bt plus 3b. Combine these similar terms, that is a plus b multiplied by t, and here 4a plus 3b, which will be a constant term. Denominator, of course, you know that they are going to get cancelled because left and right have t plus 3 and t plus 4. So 4t plus 10 divided by t plus 3 into t plus 4 will come. Cancel these two out. Now just equate. A plus b will be equal to 4, and then 4a plus 3b will be equal to 10. So this is the second equation. Now either you multiply the first equation by 4 or 3, you can subtract and get the required a and b value. So let's multiply it by 3. For the first equation, 3a plus 3b equals to 4 is 12. Subtract these two, a will become negative 2. Now put it here, negative 2 will add up with 4, so b will become 6. Now the next step will contain a as negative 2, so we'll take negative 2 out and integrate this t by 3, but it's not t by 3, it's x square plus 3. So what I'm trying to suggest here is this I1, because we haven't differentiated x square equals to t, we have to replace this. We cannot write this dt. I'm just showing it to you. There is no dt here because we haven't differentiated it. So again, you have to understand this. I'm writing just for a symbolic way. It's not actually the correct thing. So if you start doing like this, this is the error which I'm committing. So you just need to cancel this out because there is no dt, only dx is there. And t was just taken as the alias or a different name for x square. So this dt or dx divided by x square plus 3, because t was initially x square only. So dx divided by x square plus 3 can be written as root 3 whole square. And the second term is dx divided by x square plus 2 square. 4 can be written as 2 square. Now this is 1 by a tan inverse x by a. So 1 by root 3 tan inverse x by root 3. This is the first term. Minus 2 is already there. So multiply this here. The second term is what? It's 6 multiplied by 1 by a. 1 by 2 tan inverse x by 2. 1 by a tan inverse x by a, which I am applying here. And 6 is already there. So 6 multiplied by 1 by 2 is 3. So I'm just writing 3 here. And here is x minus. Please remember in the previous few minutes of this question I told you that it's not x square, actually it's integration of just dx which will come as x only. Let me just change it here, it will be just x. So integration of dx is always only x, so you can call it as 1 into dx. 1 can be assumed as 0 multiply x to the power 0 into 1, x to the power 0 when integrated will give you x to the power 1. So x minus, now I'm changing the sign because everything on I1 will come in as negative. So negative 2 by root 3 tan inverse x by root 3, then followed by 3 by negative 3 tan inverse x by 2 plus constant of integration. This is your I. Now whatever I have told you, you can have a formal reference here, which if you are doing next time by yourself, you can use this as a solution or a further reference. Don't differentiate, it's just an alias. Now we have x square here. When we multiply it will be x raised 6. It's lower than the x raised 4. The power of the denominator is lesser than the power of the numerator or the order of the numerator. That's why you can just put x square equals to t. No differentiation. Again I'm saying x square is just known by a different name, which is t here. So 4t square, because t x raised 4 will be t square whole t square square. This t square is x square. X square square is x raised 4. And denominator will be like this, and you can just equate it with a divided by t plus 2, b divided by t plus 3, and c divided by t plus 4. Now a, b, c, I'm hopeful that you will be able to compute it. Again, this is a very basic thing which you can do. So let me tell you, after you have done this, a will come as 19 by 2, 1 by t plus 1, but there is no t, it's just x square. This is I only. When we start integrating this, there will be no trace of t. You have to deal with x square only. So 19 by 2 integration of dx divided by x square plus root 2 whole square, because we are going to use a 1 by a x square plus a square formula here, and b will come as minus or negative 39 integration of dx divided by x square plus root 3 whole square. T is being replaced by x square in all the three denominators. C will come as 67 by 2, which I am writing right now, and integration of dx divided by t is x square plus 2 square. Final answer will be 19 by 2. This will be 1 by a tan inverse x by a. So 1 by root 2 tan inverse x by root 2 minus 39 1 by root 3 tan inverse x by root 3 plus 67 by 2. See, I'm just giving you a hint. This question is quite easier. The only initial steps I'm telling you, and the final steps only. So I has come like this. Let me write the final answer after, if at all any cancellations are there. So 19 by 2 root 2 tan inverse x by root 2 minus 39 by root 3 tan inverse x by root 3, and then 67 by 4 tan inverse x by 2 plus constant of integration. This is all your result. Now, as this was very straightforward question, because it seems to be a big question, but it's not. Only x square can be taken as t, and then the solution can be proceeded, and finally ABC computed. Integration is quite similar because 1 by a tan inverse x by a is used everywhere. Now this is x raised 4, x minus 1 and x square plus 1. Now you already know that x minus 1 is in the denominator. X into x square will be x cube. x raised 4 in the numerator, so you need certain things like either you divide them or you can do some other thing. What is that? You'll get in the same way with both the process or both the ways you'll get the similar answer. So this x raised 4 minus 1 plus 1 you can do. So when you do this minus 1 plus 1, what are you going to get? X minus 1 into x square plus 1. Now separate this x raised 4 minus 1 and 1. So this will be 1 by x minus 1 into x square plus 1. So this x raised minus 1 raised 4, 1 can be given any power. This can be written as a square minus b square. So a minus b into a plus b. X square minus 1 can always be written as x square minus 1 square, which will give you x minus 1 into x plus 1. So now this has become x minus 1 into x plus 1 into x square plus 1 divided by x minus 1 into x square plus 1 plus 1 divided by x minus 1 into x square plus 1. Now this two terms will get cancelled. So only x plus 1 remain. Let me tell you, when you divide this x minus 1 into x square plus 1, you can multiply. And you can divide x raised 4 by that, same thing will come. I'm just giving you another aspect or a different way. X plus 1, when it is integrated, it will be x square by 2 plus x. Let me write this first term integrated, and second term you have already done. See, 1 by x minus 1 and x square plus 1 has already been done. You can just write it as a divided by x minus 1 plus b divided by x square plus 1. It will be x plus c divided by 1 because of the denominator is a quadratic equation. Now a and b and c can be easily computed. Let me tell you, a will come as 1 by 2. So dx divided by x minus 1 will come. And what about bx plus c? So b will be negative half, so negative half into x divided by x square plus 1. And c will also come as negative half, so integration of dx divided by x square plus 1. Now you have already known this. Just add these two, x square by 2 plus x plus this result, you'll get the final result. Now dx divided by x minus 1 will be log x minus 1. And dx divided by x square plus 1 will be x square plus a square 1 by a tan inverse x by a. X divided by x square minus 1 will come as half log x square minus 1. Half into half will be 1 by 4. So let me write the final answer just for your reference, because this first one will be log, third one will be 1 by 8 inverse x by a, middle one I just showed you. So I'm writing all of this. 1 by 2 log x minus 1, then minus 1 by 4, 1 by negative 1 by 2 tan inverse x plus c. So this is your final result. Now this was just being told by me as a way to make you understand that we have already done this question. So those who have done the previous questions, you already know that how it is to be done. Who has just come to see this question, it will be difficult for them to understand how you have just showed 3 lines and you say that you have. So we have done questions like this, but there is this x raised 4 which may seem a kind of scary. But if you see that if you just take x square equals to t, that is you take some alias or different name for x square. We are not differentiating x square or t. We are just saying that just imagine x square as t. So this equation will become like this: t divided by t square, because t is x square, x raised 4 is t square. So t square minus t minus 12, and this 12 can be written as negative 4 plus 3 because you can get a negative out of it. So we can write this as t square minus 4t plus 3t minus 12. You can take t common, it will be t minus 4. Now you can take 3 common, it will be t minus 4. So we have two factors out of t square minus t minus 12, which is t minus 4 and t plus 3. So this equation, after converting it to a partial fraction, this question has become quite easy now. You can just write a divided by t minus 4, and then we can have a b divided by t plus 3 in order to get a and b, and then integrate these two terms separately. If you wouldn't have taken t equals to x square, then the problem of solving this question would have enhanced. But we have simplified it now. Now take the LCM. A multiplied by t plus 3, then b multiplied by t minus 4. In denominator we have t minus 4 and t plus 3. So let's multiply. I'm multiplying it here. At plus 3a plus bt minus 4b. Now combine these two terms, a plus b, because these are similar terms, a plus bt, and 3a minus 4b. Denominator will contain the same thing, t minus 4 and t plus 3. And if you compare it with the left, which from where it has originated, you can cancel this t minus 4 and t plus 3 like this. Now let's equate a plus b into t equated with t, that is a plus b will become what? It will be 1. 3a minus 4b, it's 0. because there is no counterpart in the left, there is no constant. So you can write 3a minus 4b equals to 0. So you can just take a equals to 4b by 3, or say b equals to 3a by 4 and put it in the first equation, or you can multiply first equation by 4 or 3 and then subtract or add. So I have multiplied a plus b equals to 1 by 4 and just added it. It's up to you how you want to find out a and b. A will come as 4 by 7. If you put a as 4 by 7, b will give you 3 by 7. 7 minus 4 by 7 is 3 by 7. So the next step will be, we'll put a as 4 by 7. But before that, you have to put or replace now again this t by x square, because we have to integrate it now. So again 3 by 7 for b and integration of dx by x square plus 3. That's what we are doing right now. So what I just told you, I'm writing it in a fairer way. It will be 4 by 7 integration of dx divided by x square minus 4. You can write it as 2 square, because we'll use the formula. B came as 3 by 7 integration of dx divided by x square plus, we are writing not 3 but root 3 square, again using the formula. We are applying the formula just now. Now dx divided by x square minus a square. So what is the integration of dx divided by x square minus a square? We know the formula of this. It's 1 by 2a log x minus a by x plus a modulus. X in this case will be x only and a in this case will be 2, and put it here. So this will be 1 by 2a. What is a? 2. So 1 by 4. 4 by 7 is already leading. So multiply this 4 by 7 into 1 by 4. You'll get 1 by 7 only, and use this formula which I just indicated you. Log x minus 2 divided by x plus 2 modulus. First part is done. Coming to the second part. Now we have to apply the formula of dx divided by x square plus a square. So integration of dx by x square plus a square will be what? 1 by a tan inverse x by a. You take a as root 3. So 1 by root 3 tan inverse x by root 3. Now 3 by 7 is also leading it. So just multiply this 3 by 7 into 1 by root 3. You can multiply numerator denominator by root 3. Root 3 will give you 3. The numerator will get cancelled. So root 3 by 7 will come, and tan inverse x by root 3 and plus a constant of integration. This is your final integration. Now I told you how to do this, but the basic idea is to make you understand and write also, because until you write, how are you going to present the answer to the invigilator or the examiner? This is how you have to write. Okay, there are certain things which are not seen here, which I told you in a different way. You can follow that. So we have x square divided by 1 minus x raised 4, x to the power 4. So we'll take x square as t now. So this will be t divided by 1 minus t square, because t was taken as x square. So this will be t divided by, or a square minus b square formula will use. A 1 square minus t square is what? 1 minus t into 1 plus t. So you can equate with a divided by 1 minus t plus b divided by 1 plus t, because we need to find out the partial fraction constants a and b, and you know this has been done by you quite a lot. So a will come as half, you already know that, and b will come as negative half. So I'll put a as half here. This will be half divided by 1 minus t. Now you don't have to write t. You have to replace this by x square now, because we are now starting to integrate again. For this b, negative half will come. So this negative I am bringing in between, half in the numerator, 1 plus x square in the denominator. Now half you can bring in here. This half you can bring in here. Integration of a square minus x square formula you are going to use. A will be 1, x will be 2 in this case. X will be x only. So 1 by 2a log. See, this is not x square minus a square. This is a square minus x square. Those formula will change. A plus x will come in the numerator. So log a plus x by a minus x will come. So 1 by 2 into 1, that is 1 by 2 log 1 plus x by 1 minus x. Half is already in front, just multiply this, 1 by 4 will come. So this will be 1 by 4 log 1 plus x divided by 1 minus x. Coming to the second term here. So you are actually integrating dx divided by a square plus x square, or x square plus a square. So 1 by x square plus a square is what? So 1 by a tan inverse x by a will come. So x square plus 1 square is there. So 1 by 1 tan inverse x by 1. So only tan inverse x will come out of this. Half is already there in front. So negative half tan inverse x plus a constant of integration. That is the whole integration you can do. Now what is step by step formulation of this question when you write? This is in front of you. There are certain things which are being done here differently. I have shown you differently. Since this question is just being done just before one question, that is 65th question or 66th question rather. So we will take x square equals to t first. This will give you t divided by t square plus t minus 2. We will take the factor. You already know how to make the factor. Then the a and b will come, and then put x square equals to t again, or t as I'll show you the reference. So this question is almost similar to the 66th question, and there are certain things. X square has to be taken t first, then you go above 1 by x square plus a square, 1 by x square minus a square, and 1 by a square minus x square. This formula of integration will be heavily used. You need to remember them when you are solving this kind of question at the trailing end of this exercise. Now this question, 63rd question, I already did. I told you a different way or different approach to solve this. But those who want to do in a different way, I will show you a different way of doing it. It's somewhat cumbersome, you can say that. But it's up to you. You know, you go to different shops, your friend buys from one shop, you buy from another shop. That means it's choice. So I'm giving you a choice. You can go back to 63rd question and see how it was done. But if you want to do it the way I am telling you, this x square plus 1 and x square plus 4 will be represented in the form of x square plus 3 and x square minus 5. So what I am trying to suggest here is that x square can be placed as t. See, even if you place x square equals to t, the numerator denominator order are same, x raised 4. So you ought to divide them. So when you are dividing them, that is the main key of division, which we have learned in question number 63 also. So what we'll do here is we'll write x square plus 3 the numerator with a negative 2. X square plus 3 minus 2 is what? It's x square plus 1 only. So essentially we are writing x square plus 1. Similarly, x square plus 3 we are writing. 4 we are writing. How we are going to write? X square minus 5 plus 9 is x square plus 4 only. But we have actually introduced x square plus 3 and x square minus 5 because of the denominator they have. Denominator is x square plus 3 and x square minus 5. That's why we have taken it. So x square plus, now I am multiplying each and everything. X square plus 3 multiplied by x square minus 5, then x square plus 3 multiplied by 9. So 9 into x square plus 3 you can write. Then multiply negative 2 by x square minus 5. So minus 2 into x square minus 5 will come. Then minus 2 into 9 will be negative 18. See, denominator remains the same. It will always be x square plus 3 and x square minus 5. So just assume that there is a denominator for all these terms, and we are going to separate these terms with this denominator. So I am just separating each term with the x square plus 3 and x square minus 5 in the denominator. So let's just take this x square plus 3 and x square minus 5, x square plus 3 and x square minus 5. And what benefit it will give us, that most of the cancellation, the integration will become quite easy. That means the first term will get cancelled, only 1 will come. The second term, if you cancel x square plus 3, only 9 divided by x square minus 5 will come. If you cancel these two, minus 2 divided by x square plus 3 will come. And this will be a separate term. We are going to integrate it separately. So x square plus 3 and x square minus 5. So now we are integrating it. So the partial fraction has already been computed, not for the last term that we will do just now. So the first term was 1. The second term was 9 divided by x square minus 5. Then we have minus 2 divided by x square plus 3. And finally 18 divided by x square plus 3 and x square minus 5. Now this term, see, first, second, third term you can integrate it easily. The fourth term, we can have these two separate terms out of the fourth term, and a by x square plus 3, b by x square minus 5, and that will get combined with the second and third term. That is, I am just doing it separately, x square plus 3 and x square minus 5 in the denominator. I am taking x square as t. It will be 1 by t plus 3 and t minus 5. You can write it as a divided by t plus 3 plus b divided by t minus 5. I am not differentiating x square and t. I am just saying that I have taken an alias or different name from x square, which I am calling it as t, and a will come as negative 1 by 8, b will come as 1 by 8. You can do that. I know that you will be able to do that. I am just writing a and b after computation. So this negative 1 by 8 and 1 by 8 will come along with this x square plus 3 and x square minus 5. Now you need to multiply it with negative 18. Just multiply it with negative 18 because I am just talking about the last term. So this will be 9 by 4. This will be 9 by 4. In the denominator it will be x square plus 3 and minus here. So minus 9 by 4 x square minus 5. Now this whole has given us two terms. So 9 by x square minus 5 will get combined with 9 by 4 x square minus 5. Negative 2 by x square plus 3 will get combined with 9 by 4 x square plus 3. Alright, these two terms will get combined because the denominator has x square plus 3 common and there is only constant term left. In the middle one also x square minus 5 will be taken and constant term will remain. So there will be a combination of that. What will be 9 by 4 minus 2? In order to take these two, first and fourth term, it will be 9 minus 8 by 4. Let me do it. So 9 by 4 minus 2 will be equal to 9 minus 8 by 4. So this x square plus 3 in the denominator will have 1 by 4 along with this. Okay, understood? Now coming to this second term. x square minus 5 and x square minus 5. So this will be 9 minus 9 by 4. So this will be 9 4 is 36, 36 minus 9 by 4, this will give you 27 by 4. So x square minus 5 will have 27 by 4, this x square plus 3 will have 1 by 4. So only one term will come for x square minus 5, one term will come for x square plus 3 as the denominator. So let me write the final thing. I hope you understood everything. So 1 plus 27 by 4, which I just computed, and 1 divided by x square minus 5 in the denominator, plus 1 by 4 and 1 by x square plus 3. And we have to differentiate with respect to dx here. Integration of 1 will be x. This will be 27 by 4. Integration of dx divided by x square minus 5. You can write it as root 5 whole square. 27 by 4. X square minus a square is what? X minus a into x plus a. But we will use the formula here. 1 by 2a log x minus a by x plus a. So integration of dx by x square minus a square is always 1 by 2a log x minus a x plus a. So I am writing it right now. 27 by 4 2s are 8, 8 root 5 log, you can write it as ln because it is log base e only, x minus root 5 divided by x plus root 5. For the final term, we'll use 1 by x square plus a square. So integration of 1 by x square plus a square we are going to use. For that root 3 square will come. So 1 by a tan inverse x by a. What is a? A is root 3. 1 by root 3 tan inverse x by root 3. 4 is already there, so 1 by 4 root 3. So you can write this term 1 by 4 root 3 and then tan inverse x by root 3 plus a constant of integration. This whole is the integration, final integration. So this is a different way of doing it. This is different from the question number 63, which already has been explained to you. Whichever way you want to do, it's up to you. Both ways are acceptable. So this is all about this exercise. Thank you so much. Have a good one. Take care of yourself.